20, 20, 22, 24. So it's a instrument A. Randy uses the two types of clocks below to manage time. Use the information displayed on the clocks to answer the questions that follow. All right. This is called analog, and this other side is the digital one. All right, analog and digital. Then, what time is this? This one is supposed to be 11:54 from this side here. 11:54, because it will soon becoming 12. Okay. Write down the time on clock D in words. D is this one here, which is 8 past 12. You can write and we say in words it's 8 minutes past 12 in the afternoon. Express the clock on clock C in 24-hour system. Clock sits here in 24-hour system since displayed time morning. So it will still be 11. Someone might say 53, 54. It's not yet 55. Already wants to visit, okay? Went to visit. A lady went to visit her mother in Millspread. She left home at the time displayed on C and arrived at the time displayed on D. So this is the start time and this is the end time. What are they asking? Or how long did she travel? So remember we say this is find out the duration. This is duration. Duration will equal to the end time minus the start time, which became the end time is D. The one in D, it's 12 hours, 8 minutes, minus the time, which is the starting, which is 11:54. End up having an answer closer to 16 minutes or 15. It's 14 minutes. Here we go. They say Peredi went to the local university to apply for bursary. She used the map on annexure A. Find the local university to apply, to find the university. Study the map on annexure A and answer the questions that follow. Identify the national road found on this map. Let's go to the annexure. The national road found on this map. This is annexure A. The national road, it's this one here, N4. We have N4. Then write down, okay, what is the general direction of pick and pay from Formula One hotel? Simply meaning someone is in Formula One and is going to pick and pay. Formula One, it's here. Formula One, it's this one. Formula One, it's this one here. And take note, look at where the north is. That means the northern part is this. So if this is your north, so this is your north. So from here, you take north, northeast. Northeast. So here we shall say north, northeast. How many sets of street lights will she pass when traveling from Enzo to Mabusa Street to Swane University? Swane University. So we are the they say how many sets of railway from Enzo Mabusa Street to from here to there. So we have these are 2, these are 4, these are 2. The answer becomes 8. Eight sets. Which direction should Bahad drive if it's traveling from Robin Ferry to hospital to the university? Which direction is it? It's from here. Yeah, the person will take the southern way because this is north, south is this other side. So it will be the southern direction. Southern direction. Question number 2. Mpo and Mantla are traveling together from Krugersdorp to Pretoria to attend a meeting to organize Mathematical Literacy Olympiad. Study the map in Annexure B and answer the following questions. Which neighboring province? We go and we look at the map. All right, this is the map, and they ask us which neighboring province is situated to the south of Gauteng? South of, if this is north, the south is this other side. What's the neighboring state? It's Free State. Free State. Identify the scale shown on the map. We come here. This is the scale shown. This is a bar graph. Bar scale, sorry. The bar scale. Name the last town they will pass before they reach Pretoria. You see, it's a Centurion. Look here. They're from here, but this one here, it's the last town before you reach Pretoria. So here the answer is supposed to be Centurion. The last town met is Centurion. After the meeting, Marshall decided to visit his friend Brock's spirit. He detailed write in detailed instructions to direct him from Pretoria to Bronx Spirit. Write down, write detailed instructions to direct him from Pretoria to Bronx Spirit. This will be from Pretoria, take N4 on your right hand. How many toll gates will Martha pass on his journey from Krugersdorp to? So here we see it's only one because it's Krugersdorp way here. He has to move again. So there we go. Then there is this from there up to there. It's only one T. H. Here we said it's one toll gate. It's this one here, only this one. There's no any other. Okay, the actual straight line distance from Krugersdorp to Bronx Spirit. What you're going to do, you take a ruler, then you measure. Take a ruler, then you measure. Take a ruler, then you measure. We are measuring from Krugersdorp to Bronx Spirit, straight line. So for one photo of Krugersdorp to the other. These answers will change according to our rulers. I have measured and I've got 90 millimeters. This is the distance I've measured, but it's not yet actual. 90 millimeters. It's not yet actual. So how do we turn it into actual? I'll go and measure also the distance on the scale. The bus scale. I'll measure the bus scale. This distance. First, I've measured the distance. I measure the distance from here to straight. Go to the answer as 90 millimeters. Then I should come also here and measure my distance. I'll measure from here up to there when I measure from 0 to 75, I have 60 millimeters. Simply meaning the 60 millimeters are equivalent to 75 kilometers. Okay, we need now to go back and we change the distance. So we've seen that if you have 60 millimeters, you have a distance of 75 kilometers. So cross multiply and you get 9 times divided by 6. Ninety times 75 divided by 60. So I have the answer as this much. 112 hours. Mpo decided to take a bus from Johannesburg to Bloemfontein. The bus stopped twice for 20 minutes each time it stopped. So in other words, it has spent 40 minutes. The bus departed at 7:20 and arrived in Bloemfontein at 11:30. She claimed that they were traveling at an average speed of 120 kilometers. Verify the claim. Number one, they told us to use an extra C. So before we verify the claim, we need to know the time that was spent. So we shall take the time they arrived, which is 11:30, minus the time they left, which is what? 7:20. Here we have 10 minutes, and here we have 4 minutes. Remember, this person spent 20 minutes stopping, so the bus was not traveling. So we say the time spent minus 40 minutes. Minus 40 minutes. Now, when you subtract the 40 minutes, what do you remain with? This could be 3:30. Subtract the 40 minutes from here, you remain with 3:30. Change this to hours. So this will become 3,5 hours. These are minutes. I had to change them to hours. So it's 3 hours plus the 30 divided by 60. Why am I dividing by 60? I want also this to become hour. Okay, let's go to our next chart. Next chart C. This is the next chart C. So we've got the time, which is 3.5 hours. So we need to prove speed. Remember, speed, we said it will always be. There's that triangle there. Please don't forget it. We try to S equals to D over T. So our speed here should be distance over time. Do we have the distance? No, but they told us to use an extra C. The distance you're looking for is Johannesburg and Bloemfontein. We go to this is Bloemfontein. You scroll down. Where does it meet Johannesburg? So this is the distance covered. Distance, this is Bloem. When does it meet Johannesburg? This is the distance. It's 398. So we shall say 398 divided by 3,5. So they have 113, so it's correct. Verification, sorry, their calculation is what? Correct. All right, this marks the end of question number 2. question number 3. We look at question number 3. Shaylee has a catering company and she bought an run to prepare tea for her customers. She uses a bucket to fill up the run, and the dimensions of the run and the dimensions of the bucket are indicated below. Study the information below. All right, he bought a run and this, okay, the run, it takes a cylindrical shape and the bucket takes a rectangular shape. All right, what do we see here? We see the run, it's already given to us here. This will be the diameter. This part here is the diameter. This part here, it's the diameter. This is the height only for the base. But then they have told you, when you look at this, look at the scenario here, we have the height of the run, excluding the lid, is 380 millimeters. So the height is from these handles went up to down here. The height is 380 millimeters. But in the end, you will need to change it to centimeters because we have these centimeters also here. So we shall look at that. Anyway, let's continue with C. Define the term volume. Volume. All right, there we go. We say volume. Volume is the space occupied by an object. You know, volume and capacity, they are two different. Space occupied, for example, if you get a box, you put it in a corner, how much space does it take? That's what you're looking. But now, capacity will be how much can that box hold? How much can that box hold? Those are two different things. Space inside the box is capacity. Outside, how much space does the box? How much space does the box take? It's supposed to be volume. All right. Determine the height of the bucket rounded off to the nearest centimeter. These are 6 marks. All right. Take note. For us to determine, because now we are the bucket, we are looking at the bucket, and the bucket is what? Rectangular. The bucket is rectangular. So they have given the formula that they used. Ask yourself, do you have the volume of the bucket? Because we already have the breadth and we have the length. The height is missing. The height is missing. So this part here from here up to down there, this. So we're going to use the volume, we use the length, we use the breadth, and we shall look for the height. Anyway, let's continue and we say, since the bucket, the volume of the bucket is 18,46 liters. So we shall change the 18,4 liters into centimeters using this fact here. So the volume of this bucket here, it will be, the volume will equal to 18,46 multiplied by 1,000. The reason why I'm multiplying by 1,000, I want it to become centimeters cubed. When I multiply by 1,000, I will end up having 18,460. These are centimeters cubed. Well and good, I've converted. Now I'll come and substitute into the formula. So the volume is 18,460, giving me the length of 30, the breadth of 22, times the height of the unknown. All right, let's continue. So simply meaning, we are saying they give the volume of the bucket. They gave the volume of the bucket in the form of liters, which was 18,46 liters. Change these liters to centimeters cubed. How do we do that? We shall get the 18,46 times 1,000. So the answer here became 18,460 centimeters what? Cubed. All right. So we already know the length as 30 centimeters. We know the breadth as 22 centimeters. The height is missing. So they have told you they got their volume by L times B times H. Substitute in the V is, volume is 18,460 equals to the length, which is 30, times the breadth, which is 22, times what? H. When I multiply 22 times 30, I get 660 what? H. Either we are looking for the H, so we shall divide through by 660, divide through by 660 on both sides. So my H became 8460 divided by 660. So my H is 27.96. This set to the nearest centimeter, which becomes 28 centimeter. So the height is 28 centimeter. All right. So the height there is 28 centimeters. You're asking us, show that the circumference of the ring is 138,248 centimeters. Circumference, definitely. I told you this is our diameter, which is okay. So how to get the circumference? The circumference they've told us, we shall take pi times d, which is d stands for the diameter. So we shall come here and say 3,142 times 44. We shall take 3,142 times 42. Three comma 142 times 42. Sorry, 44. 44. So 3,142 times 44. The answer indeed is 138,248. These are centimeters since it's circumference. All right, here we go. Charlie boiled the water and wrapped the outer part of the urine, the steel part, with foil. What is the importance of wrapping the outer part? So one might say to keep the water warm. Keep the water warm. Someone might say for insulation. For insulation. Insulation simply meaning you cover something and you prevent it from losing heat. Someone might say to prevent heat loss. Ne? All right, determine the radius of the urine. We said radius will always equal to diameter divided by 2. We've already seen the diameter is 44. We divide that by 2, and the answer became 22. These are centimeters. Hence, calculate the area of the urine which was covered with a foil. Remember, let's go back to the diagram here a little bit. Now we are looking for this area here, from here up to here. This is the area that we are looking at. You see that? We are not looking at the base. So this is what I told you. Now, when we come here, they've given us a formula. 2 pi r times h. All right? So 2 pi r times h. So the h, it's going to be this distance here, which will be 38 miles. Subtracting the 4, because from up here up to down, it's a 380 millimeters. Change it to centimeters, we get 38 centimeters. You see that? Of the 38 centimeters, remove the bottom, which we remain with 34. All right. So our height now is 34 because we're only looking at the silver covering. So here we shall say area equal to 2 times pi, which is 3,142, times the radius, which is 22, times the height, which we've just got as 34. Together? 34. We want the answer in centimeters. Everything is in centimeters. Let's continue, and we shall say, so 2 times 3,142 times 22 times 34. The answer became 4,700, 43 centimeters squared. Hence, calculate the area of the urine that will be covered with the foil, the silver part, the steel part. Either that one there, it's going to be covered by the urine, which is, in other words, we are insulating. Determine the volume of the urine. Now, they told you the volume will equal to pi r squared, which is 3,142 times, what's the radius? The radius is 22 squared, times, now the height of the urine is going to be, 38, it's fine. 38 is fine. Volume, but when you look at it critically, it cannot be 38. Why? Because the base does not carry water, right? The base carries the boiling part, but the water starts from here to this part here. That's where the silver part is. Anyway, so a ladder will use 34, and we shall end up having our answer as 3,142 times 22, don't forget to square, times 34, times 34. So here the answer that we get is, the answer we have 51,704, 75 centimeters cubed. Don't forget that, right? Shall we use the bucket to refill the urine? Then the bucket holds 18,46 liters of water. Determine the number of buckets needed to refill the empty urine. Then we shall say this. We shall take the volume of the urine divided by the volume of the bucket, because we are looking for how many buckets will fill up. So the volume of the urine is 51,704,75 divided by the reason why I have this is in centimeters cubed, so I had also to change this to centimeters cubed. So I got the answer there as 51,704,75 divided by 18,460. So I have 2,8. I have 2,8. I have 2,8. I have 2,8. So these, remember, we are looking for buckets. These are approximately 3 buckets fully. The third one, you won't use it fully. All right. Question number 4. Question number 4 says, Sipo owns a bakery and makes and sells bread and cakes to the local community. A fast-selling item is banana bread with custard. The recipe to prepare the banana bread is indicated below. Study the recipe and below answer the questions that follow. Convert 7 inches to centimeters. We shall use this factor here. This will be if 1 inch equals to 2,54 centimeters. What about the 7 inch? What will they be? So it will be 7 times 2,7 times 2, which becomes 17. 17,73 centimeters. All right. Petals, we look at 25 kilograms of sugar, and the person claims that this can prepare banana bread to serve more than 100 people, more than 150 people. That's the claim. So let's see if the claim is valid. So we need to verify the claim. Here we go. We say I'm answering 4.1.4. 100, 150, we go to the next here we have, this is the sugar that we are looking at. This sugar here serves 8 people. So how much do we need for 100? And okay, we see how much shall we need. Now, we shall come here and say, if 150 grams, they are for 8 people. 150 grams are for 8 people. 150 grams are for 8 people. 8 people. Then we shall ask ourselves, what about if we have, because now he bought 2,5 kg, how many grams will this be? We shall change this to by multiplying by that, which becomes 2,000 grams. We shall ask ourselves about the 2,500 grams. How many people will it serve? So we shall multiply by that. We end up 2,500 times 8 divided by 150. 2,500 times 8, you get 20,000 divided by 150. You have 133,33. So it can only serve. So the claim is valid. The claim is invalid. The claim is invalid. Someone else would have changed. Someone else would have changed. So the other one would be, we would change the 150 grams, we change it to kilograms by dividing by 1,000. So the answer would become 0,1, 0,15, 0,15. These are kgs. These ones, they serve 8 people. All right. What about if someone has 2,5 kg? What will it be? So you would have changed that and you say, still we shall call this letter any letter of our choice. Cross multiply 1, 0, 1, 5 0,15 kg times the unknown letter equals to 2,5 times 8. All right, 2,5 times 8, you end up having 20. These are 20. Then we divide through by 0,15. So 20 divided by 0,15, still get the same answer. So remember, we are looking for the number of people. So these are the people. The unknown even closer to 150. The claim was it will serve more than 150. This is not more than 150. So the claim is invalid. This is question 4.1.4, this one here. So the claim is invalid. All right. We come to express the amount of sugar. Express the amount of sugar to butter in a simplified ratio. Let's go up there. Butter is 75 grams, sugar is 150. In that manner, I'll come here, say 150 is to 75. I divide through by the smallest, I will end up having 2 is to 2 is to 1. Simply meaning, wherever you have 2 parts of sugar, you have 1 part of butter. That's what it simply means. Question number 4.2. Shall use the addendum here. This is the addendum that we're looking at. Yes, they're telling us, Sipo lives in Craddock and travels every weekend via Enton-on-Sea to the restaurant in East London. He claims that his return trip covers 1,000 kilometers. So remember, return trip, it's going and coming back to and fro. So we are going to multiply the distance covered. But take note of the place we have Craddock via Enton-on-Sea, then up to East London. Let's go there and you see. The person is here. Yes, the person is here. All right, the person is going through this part here. Then he comes to this. He does not stop. He goes up to East London. So here the distance covered is 192. So put it aside. 193 plus. This is from here up to this distance. Now, from the road here up to here, it's 74. We shall add 74. From this town, Kensington, we go to up Port Alfred, which is 24. Then from Port Alfred to East London, they're telling us it's 158. You add 158. See that? So when you add 193 plus 74 kilometers plus 24 kilometers plus 158, you end up having 449. These are the kilometers covered. But this is only one trip. Well, it's going only. Then when you're coming back, multiply by 2, and we shall end up having 890. So the statement is invalid. Statement is invalid. The statement is invalid. Remember, we said we shall take the distance from East London. We add on 74. We add 24. Then we had 158. These are the distances covered. So we ended up having the distance as 449. These are kilometers. Multiply by 2. The answer became 898 kilometers. This is not 1,000, so it's invalid. The claim is what? Invalid, because it says the trip covers 1,000 kilometers. No, it's less than 1,000 kilometers. Had he said the distance is less than 1,000 kilometers, then the statement would be valid. 4.3, we are looking at this probability still. And again, they brought a tree diagram. SIPO also works a catering company for, SIPO also owns a catering company. For dessert, clients can choose from the following options. The base, it has 2 options. It's either banana or marvel. Then top, it's either yogurt or custard. Then decoration, it's either strawberries or chocolate flakes. You understand? So you expect to have, expect to have 30 what? 30, you expect to have 30 branches. One, it will be for the base. So the base is either bread or pudding. Then this has to split again. You either get yogurt or custard. Yogurt or custard. Then it has to split again. Either get strawberries or meve. Strawberries or meve. Stays, it goes on splitting. All right. They're saying in the tree diagram, annexure E represents the different options of the dessert study. Of the dessert. Study the tree diagram. Study the tree diagram and answer the questions that follow. Complete the tree diagram by using the values of I, by writing the values of I, Roman numeral 1 and Roman numeral 2. Let's go to the diagram and we see. This is how it looks like. Together. So what you take note of, this is the base. These are already done. It's fine. So here we are looking at it was called the what? The top. We look at the top. These are the tops. Remember the tops, we either have yogurt or custard. Yogurt. Another thing is that you look at the second branch. So this is complete. Nothing is missing. That means also here what's missing? It's a Y. Then when you come to this, it's either strawberry or marvel. Strawberry or marvel. Strawberry or... So you also look at the others. You see, they all have SS. Also use here what is missing is what? S. So we go back to the question. So here I, it's y, and this is s. How many possible outcomes are present? Sorry, how many possible outcomes are represented in the tree diagram? Go to the tree diagram. Let's look at the possible outcomes we have. This would be B, Y, S. Here we have B, Y, M. We might have B, C, S, B, C, M. Here we can have P, Y, S. Then we have P, Y, M. We have P, C, S. We have P, C, M. So how many possible outcomes do we have? We have 1, 2, 3, 4, 5, 6, 7, 8. So we have the possible outcomes that we have here are 8. Out of the 8, what's the probability that of choosing a dessert with banana base? So we shall look at, out of the 8, which one starts with the B? So we have 1, 2, 3, 4. So we shall come down here and we shall say 4 out of 8. Don't forget, leave it as simplified form, which is a half. Had they asked for decimal, it would be 0.5. Percentage would be 50%. This marks the solution. This marks the end of our solution. In Table 1 below is a list of explanations and definitions of concepts used in mathematical literacy. Table 1 explanations and definitions of concepts. A, the distance from the center of a circle to the outer part of the circle. B, the usage of cardinal direction, i.e. north, south, east, west, to describe the location of one point to another. C, the path or boundary that surrounds a circular object or surface. D, a position in which is not exact, but roughly shows the location of an object. E, a measure of body fat based on the height and weight of an adult person. F, the total area of all surfaces of a 3D shaped object. G, a special type of diagram used to determine the outcomes of an event in probability examples. H, arrangement of something laid out, such as the structure features of a mall. I, the ratio of the distance in real life compared to the distance on the map, on the same distance of the map, the rate of covering a certain distance over time. When we just look here, mere looking at this, when you're answering, this has to be, this is speed, because we have distance and the time. And remember, this is at a rate. A ratio, this is supposed to be a scale. Arrangement, this is the same as a layout in a form of a floor plan. A special type of diagram, this is called a tree. This is a tree diagram. This is surface area. That's surface area. A measure of body, this is supposed to be BMI. A position which is not exact but roughly shows the location of an object. This could be general direction. General direction. The path of this is supposed to be circumference because we are looking at a circular shape. So here we have circumference. There we go. Using also this one here is to describe the location of one point to another. It can be route description, or we can say general no direction. The distance from the center of a circle to the outer part of the circle is supposed to be the radius. Anyway, let's look at the question here. They say, use the information above to write down the letter of the explanation or definition A to J for each of the following concepts. BMI, we've already seen it as E. Circumference, we've seen it as C. The path around this circumference. E was BMI. Then the map scale, it's I. Compass direction, this could be B, direction. And the tree diagram, we've seen it as G. Possible outcomes in probability. 1.2. Use annexure A. Annexure A shows the layout of a vegetable garden with different plant beds as well as table 2, which shows plants with their partner plants. Use annexure A to answer the questions that follow. Let's see annexure. All right, this is the annexure here that we have. And the question is, identify 3 plants that have cabbage as a pattern. Here, look for cabbage. We have cabbage 1, cabbage 2, cabbage 3. Do we have any other cabbage anyway? So these are the plants. We have potatoes, onions, and cucumber. So our answer there becomes we have potatoes, cucumber, and onions. Determine the number of partner. Determine the number of partners of plants found in bed 4 of the vegetable garden. Let's look at the annexure there. It says bed 4. Bed 4, these are onions. So determine the number of pattern beds found in bed 4. So if these are the onions, number, we have 1, 2, 3, 4, 5, and 6. So the answer there is supposed to be 6. We are determining the number of pattern plants. So we said 6 partners of the plant. Name the pattern plant which appears 4 times in the pattern columns. Name the plant that appears in the pattern columns. These are the columns, these ones. These are columns that appears 4 times. When we take note here, we look at number 1 here we have. We have meat. Is there any other meat somewhere else? It's nothing. We have heavies. We have any other heavies around here? Nothing. Dale, we don't have any. So we have, let's look at, we have, here we have beans. Come down here, we have beans. 4 times. We have beans. And we have beans. So beans appear 4 times. Someone would have said, because if you check corn, that's 3 times. Cabbage, we saw it already, it's 3 times. Peas are twice. Let us, it's twice. Tomatoes, it's once. Very once. Radish, one. Twice. It's twice. Drill, it's twice. Squash is once. Onion is once. Beetroot, it's twice. You see? Which one appears 4 times? Meat is once. So that appears 4 times. These are beans. Have the answer there as beans. Give the general direction of search from onions in the vegetable garden. It's search from onions. We shall check the search. Garden 1 from garden 4. From. So meaning you're here and you're heading this other side. But take note. Look at the compass direction. It says that this other side is the north. So this is your north. North. Simply means if this is north, this is what? West. This is south. And this is what? East. So your answer there has to be east. 1.2.5. Some of the plant beds in the vegetable garden contain more than one type of plant. Write down the bed number of these plants. We have, let's come here, let's see. Bed numbers. So when you come here, we have 3. 3 has tomatoes and greens. Then when we come to 7, it has okra and tomatoes. No any other. So we go in and we say it's bed 3 and 7. All right, the sketch below shows a pedestal and a diagram of the pedestal with its dimensions. The pedestal can be used as a stable plant stand or an extra seat. All right, then they are saying, by the which shape does it take? It takes a cylinder, a cylindrical shape. It's a cylindrical shape. So choose a formula A, B, or C below, which can be used to calculate volume of the pedestal. Remember, you said it's a cylinder, and in your head, you know volume equals to base area times given height. This is the general formula for volume. So the base area of this cylindrical is a circle, so you need to look for pi r squared h. So you come here, volume of a cylinder. Volume of a cylinder equals to pi r squared. So we shall come here and look for which volume. This one here? No. Which one? This 2 pi? No. My formula doesn't have 2. So volume equals to this, then this is the right answer. So the answer here is supposed to be C. We have 1.3.2. To write down the unit of measurement for the volume of the speedo using the given units in the diagram. Remember, they said write down the units of measurements of volume. Volume. For area, the units have to be squared. Volume units have to be cubed, whereas perimeter units remain the same. So they are saying write down the units of volume for the pedestal using the given unit in the diagram. So the units that we see in the diagram, they were millimeters. So still here we shall write millimeters cubed. Don't forget that because you're looking for units of volume. Convert the height of the pedestal to meters. When you look at it very clearly, we have the height being 124 millimeters. So 124 millimeters, we want them to become meters. Remember very well that millimeters are the same. To change millimeters to meters, this is small to big. We need to divide together. So we divide by 1,000. So we shall also come here, we divide this by 1,000. And the answer becomes 0.124 meters. That's the answer there. We've changed the pedestal, the height to meters. All right. We look at question number 2. Question number 2. We are also looking at our next chapter. Question number 2.1, they tell us to look at annexure B. Annexure B. Let's go there and you see how it looks like. This is the annexure. So we are looking at this. This annexure B is about assembling an item. Ring light. These are the items that they're going to assemble. Then we have a tripod, panty lid, then a panty lid again. Then we have a cell phone holder. All right, these are some of the directions given. These are the some instructions given. Then some instructions are missing, like 1, 2, and 3. So this one here, it shows that this is how it will look like after after being assembled. All right, let's go to the questions and we see the question that they want us to do. Tell me the total number of items needed to assemble the ring light. We go there and we see, we count them. Total number of items. Here we have 1, we have 2, 3, 4, 5. Please, we don't count the cell phone because we don't see anything, guys. We just have a cell phone holder. All right, then the answer there becomes, there are 5 items, sorry. Find the list, the item that will be used as a ring stand. The item that will be used as a ring stand. We go back here. This is a ring light itself. This is a tripod. These are too small to be stands. So it's number 2, which is called the tripod. The reason why it's called a tripod, because it has 3 legs. So here we shall write it's a tripod. Is the direction of the arrow in the diagram B clockwise or anti-clockwise? So we come in diagram B. There's a small direction. If you can't see it, look at the arrow. The arrow goes that other direction. The person turns around from right to left. Together. So if you want to know whether it's clockwise or anti-clockwise, you need to know how does the wall clock move. This other direction, like this. So also this one here. Imagine this clock was here. So look at it. So the answer here is supposed to be clockwise. It's clockwise. Match the following instructions with the correct picture. F, G, or H. Cell phone holder. Let's go there and we see. Clamp the cell phone to the cell phone holder. Clamp the cell phone to the cell phone holder. It's what? H. This is the phone being clamped inside here. Together. So it's C, H. Install the tripod on the pan tail and rotate until tightened. Install the tripod. So you're looking for the tripod and the pan tail. Let's go there and we say tripod and remember we are looking for either we are using these options. We have these ones that are missing. This is already taken now. And this one. So of these two diagrams, which one has a tripod? So it's what? It's G. Why? I'm taking G because it has what? A tripod. And remember there I was looking for a tripod and a pat tail. So it's this one here. And this is the tripod. Okay, let's go there and we see. So it's supposed to be G. So F is nowhere to be divided by 10. You get 1,2. These are centimeters. So now your volume would equal to so this is your volume, centimeters cubed. 5 max. This is when someone changes the measurements that we have already here. We change this to centimeters, change this to centimeters, which is 3,5 times 100, 4,8 times 100 centimeters. All right, that is it. Okay, 3.1.3. 3.1.3, it says 3.1.3, it says the ready mixture plus size available in bags. 1 bag is needed for every 15,000 centimeters cubed. Determine the minimum number of bags needed to plaster the 2 walls. Remember, we've just looked for the volume. So volume of the plaster divided by the volume for 1 bag. So the volume for the plaster, it's just, we've just got it as 473,937 centimeters cubed divided by 15,000. You get your answer as 18,26. This simply means they need 19 bags. Why? Someone might say that 2 is 2 here, and yet we usually round up when this is more than 4. So the reason why I'm rounding up, it means the person needs 18 full bags with part of another. So where will you get this part of it when they don't sell in half bags? So they need another full bag. However, they won't use it fully. They will use part of it. That's why she needs, or he needs, to buy 19 bags. Determine the minimum number of bags needed to plaster the 2 walls. 19 bags. One auntie would also like to have all the old conics in the bedroom where the 4 walls meet the ceiling replaced. Now take note, the conics are these white, those ones wall ceilings at their places. You have that white part that holds the ceiling. It's between the ceiling and the wall, either. So they need to replace them. In other words, they want, because now here it will be direct perimeter, which will be perimeter. Okay, it's already given here. So remember, it covers the same, like the measurements of the room, the floor of the room. So right. So here it says we're not to like, they never told you to change anything. So you leave them in the units that they are in. So the length, we saw it as 4,8 plus the width, which is 3,5. Do that for me. So perimeter will equal to 2 into 4,8 plus 3,5. 2 into 4,8 plus 3,5. And your answer becomes 16,6. Don't forget the units. 16,6 meters. This is perimeter. At the store, there are 5 available brands. Unfortunately, not to forget the name of the specific brand. If she randomly selects one of the available brands, determine the probability that she will select a specific brand. So out of the 5 brands, it's 1 out of 5. They said probability. So if you do stop here, it's fine. Or if you go ahead and show that it's this much, it's fine. Even those ones who show that's answer becomes, don't forget to put the 20%. All right. 3.2.2, there is a 0.75 probability that the dampers will appear if the incorrect brand of the ready mix plaster is used. Determine the probability that the dampers will not appear if the incorrect ready mixture is used. This is straightforward also. If 0.7, this is positive, what's remaining to make it negative is 0.25. So probability here it's 1 minus 0, and the answer becomes 0.25. The probability scale below shows the likelihood for various probability. Write down the likelihood that best describes your answer given in or given to question number 3.2.2, which is 0.2. The answer is 0.25. 0.25 is 0 because this is 0%. We have 0.25, have 0.5, have 0.75, and it goes on. So probability, this is where it is. It's less likely. it's likely. Question number 3.3.1 says determine the time that Unat must start mixing the first bag of the ready mix plaster if she wants this bag to be ready for use at 8:05. All right, we're going to analyze how much time do we need. Mix the water and the plaster for 4 minutes. This is the first time that we have. Do not overmix. Allow the mixture to stand. You need 3 minutes more. Then mix again about 2 minutes. So all in all, you have around 9 minutes. You have 9 minutes. Now, if you want the mixture to be ready by 8:05, simply meaning you're going to come to 8:05 minus the 9 minutes, which is so he has to start at 7:50, 7:56. Oh, you can do it this way. Of this time, subtract the 4 minutes. You remain with 8. 1:08 of 1:08, subtract the 3 minutes. You find out that you have 7:58 of the 8 minutes. Subtract the 2 minutes. You end up having 7:56. If this was in the morning, no one plasters at. Okay, you can plaster at night, but it's rare. Calculate rounded to 2 decimal places. How many gallons of water she will use to mix 5 bags of plaster if 1 gallon equals to this much? Let's go back to analysis here. It says we need 7 liters of water for 40 kg bag. That means it's 1 bag needs 7 liters. If 1 bag needs 7 liters, what about 5? How much liters do they need? So it will be 5 times 7, which equals to 35 what? Liters. We don't want this in liters, we want it in gallons. So we shall divide this by 35 divided by 3,7, 8541. So he needs approximately 9,25. Let's say to 2 decimal places. 25. These are what? Gallons. Okay, there we go. This one needs 4 marks. I was wondering why, but you look at the formula, it's a little bit incomplete. You need to know because we need to see the subject. Substitute. You already have the F as 73,74. Substitute, you get 73,74 minus 32 equals to 1,8 times what? C. So because you want the C, divide through by 1,8 on both sides. Divide through by 1,8 for both sides. When you subtract, you have 41,4 over 1,8 equals to C. So here became 23 degrees Celsius or centigrade. Look at question number 4. The layout plan of the resort is shown below. The resort has a rectangular swimming pool and a tennis court. There is an overgrown area in the middle of the resort where local wildlife can be viewed from the lookout point. The area is surrounded by houses. First question says, determine the total number of houses in this holiday resort. Houses, they look like this. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. We have 12. We shall say we have 12 houses. A person standing at the lookout point facing north views houses that are in the northwesterly direction. Give the number of 2 houses viewed. All right, let's look at the campus. Look at the campus, how it's facing. It's like it shows that this is what? No, if it's like that, and this is east, this is west, this is that. So someone is seeing. So the person is here. So it's supposed to be house 2 and 3. House 1 and 2, sorry. House 1 and 2. Point 2.1. The owner of the holiday resort plans to build a cylindrical pool. The picture below shows the existing rectangular swimming pool and a cylindrical swimming pool, which the owner plan to build at there. Give one reason why you think the cylindrical pool is designed for small children. It's not that deep. It's 1 meter deep, whereas this is 1.6 centimeters, 5 centimeters deep. Explain the meaning of the capacity. Capacity, we are saying amount of substance an object. An object can contain. Amount of substance an object can contain. When you look at an object, we are looking at a container. We look at a container. Okay, you may use the following formula. They're saying calculate rounded to the nearest liter the difference in volume of the 2 swimming pools. Different liters, but they have given us volume. They didn't give us formula. Anyway, let's look at that. So cylindrical is the first one, which say volume equals 2 pi r squared h, which is 3,142 times what's our radius. Now when you come here, we say we are given the diameter. Diameter, you need the radius, you get the diameter divided by 2, which is 3,7. So we come back here and you say 3,5 squared times the height, which is already what? 1. Don't forget to square. So here we have 38,895. These are meters cubed. Put them aside. And they said, remember you're looking for the difference, is the subtraction between the volume of the two swimming pools. So the other volume is L times B times H, which is 6,2 times 3,25 times 1,65. So here we have 33,245 meters cubed. Subtract the two, we end up having end up having 5,242. These are meters, right? But the question wants you to round up to the nearest liters. And they have told you that if you only have 1 meter cubed, you have 1,000 liters. So let's multiply the ABC times 1,000. Yeah, the answer becomes 5,242 liters. Okay, the total inner area of the surface of the cylindrical will be tiled. An additional 10% tile was purchased. Give one reason why additional tiles were purchased. You can say for cuttings. You know, tiles are cut. All right, to cater for cuttings. Another thing to cater for breakage when it breaks. The tailor states that he requires more than 100 boxes of tiles to complete the tiling. Verify showing all calculations where the statement is valid. All right. Shall use the formula that we have here. I'm doing question number 4.2. Part B. First and foremost, we shall look for the area, whereby we shall say 3,142, which is the pi times the radius. We've already seen it as 3,5 into brackets 3,5 plus 2 times the depth. So there we go. We have 3,142 times 3,5, which is 10,997 times 55. So this is 60,8435. These are meters what? Squared. Meters squared. So meters squared, remember we have, okay, that's the area to be covered. Then for you to find out the number of tiles to be used, we shall get area to be covered divided by the area of only one tile. So we shall get the 60 divided by over. Look at the measurements for the tiles, 20 centimeters, and also change it to meters, which is 0.2 times 0.2. So we have this much, 0.8. Remember, these are tiles. So meaning you will need tiles. Then in boxes, how many will they have? Each box carries 16. So this stands at 96. But remember, he has to cater for 10%. So we multiply by 1,1. 1,1, you have 0. So 100,0. Correct. This is more than the boxes in the scenario. All right. 4.2, the steps you need to know. 1, look for the area to be covered. The surface area of an open cylinder. Then look for the area of only one tile. You divide the two. You get the number of tiles. Multiply or increase it by 10%, which is the same as 100 plus 10 divided by 100. So this here you get the number of tiles. Then afterwards, pack them in boxes. So you divide by 16 because each box carries 16 tiles. Look at that scenario here. I'll go through it again. Area to be covered. This is the area for the cylindrical swimming pool. So we shall start with this formula here, which will say 3,142 times, remember the radius, we got it as 3,5 into brackets 3,5 plus 2 times depth, which is already as 1. So here we go on and we say we got this as 10,997. Since there's no symbol here, put a multiplication sign times 50, sorry, times 5,5. Which we get as 60. Please take note, these are not tiles. This is the area to be covered first. Then let's look for the area of one tile. But take note, the measurements for it's 20 centimeters by 20 centimeters. They have to be in meters. So divide by 100, divide by 100, which is the same as 0,2 times 0,2, which is the same as so also now this qualifies to be meter squared. So we look for the number of tiles now, which is the area to be covered divided by area of only one tile. So here becomes 60,4835 divided by 0,04. Whereby you get the number of tiles will be 1.5, which is 1,512 tiles, 0.09. So from this moment, we increase because they said an increase of 10%, an additional. So we multiply by 10 over 100 plus so you end up having the answer as these are tiles. We want to pack them in boxes, divide by 16 because one box carries 16. So the answer you get it as 103 boxes, 95. Remember, boxes are not sold in halves. So here we need 104 full boxes. That's what we need. Okay. Question number 5. Question number 5 requires us to also look at the annexure C. Let me stage annexure C here. Annexure C, which is this one here. All right. You read through this scenario. As you read through, please you count also. These are 2 people plus the 3 friends. So all in all, these are how many people? 5 people. That's what you have to know. They are driving to Snipers. Where is it found? It's found in KwaZulu-Natal. They will travel from Johannesburg and stay at this place here. Afterwards, I think they will continue. All right. We go and we see. The next year shows the route map to Makosi. Use the information above and answer the question. And use the information above and the annexure C to answer the following questions. Write out the road number on which they will travel from exit 99 to Brewer. Let's go there. They are here. They are here. They enter using this. And they said which number they, because they are coming to this place here. So which road number? It will be R600, R6117. Give the distance from and back to Inver. Let's come back here. From here to there, the distance is this one here. Distance is 6 kilometers. We're driving 2 kilometers from Inver and the road split to the left. Okay, the road splits to the left and the right. State in which direction, left or right, they must drive. Remember, they have come from this other side. They come. They reach there. They need to come here. This goes, but it does not, it ends nowhere. So we come here. So if they are here, please, you sit in their place. So this is the right-hand side, and this is the left. Definitely, they will go left. They will use left. They will use left. Let's look at the question here. 5.4. 5.1.4. It is 16 kilometers from Hungary to Makotsi. The distance between Mankosa and the hotel is 4.4 kilometers. I get how much kilometers after the split in the road. In the road and the hotel indicated H. Okay, let's go there and we see. They are telling us the total distance. The total distance from Hungary to Makotsi is 16. From here up to here, you've covered a distance of what? That's the total distance, 16. But they want to know what is the distance from the split to this place here. Because from here up to there, we have 2 kilometers. Then what about from here like that? This is what we are finding. Because I said from here to there, it's 4.4 kilometers. So in your head, it has to be 2 kilometers plus the nothing kilometers, I'll call them H, plus the 4.4 kilometers. It should add up to 16 kilometers. So the 2 adds with the 4 this much, you get 6.4 kilometers plus the H kilometers that we are looking for, which equals to 16 kilometers. The 6.4 jumps over, it becomes a minus. So the distance covered here, the same as 9.6 kilometers. The distance from here to the 9.4. All right, let's look at question number 5.2. 5.2. 5.2, you look at the table clearly and you analyze it. Owner offers 2 sleepers and 6 sleepers accommodation. Give a possible reason why there is a surge on a single night stay. You can say generate more income in one night. Generate more income and let me see night stay to encourage encourage people stay longer. Because if you stay longer, you don't pay a surge. But when you sleep only one night, you need to pay 300 to, sorry, 200 to 300. You know, a surcharge is an extra amount that is payable. It's like interest, but it's not interest. Oh, another one would have been for security reasons. If you happen to break anything in the motel, you need to pay for it. All right. Name with a reason. A cottage you would recommend for the group to book. I would recommend them to take six sleeper, since they are 5 people. So they will all fit in one room, where they will put, one cottage, and it, for security reasons, they will all be safe. All right, 5.2. 5.2. 5.2. 5.2, 5 marks. It says, now states that the total cost for accommodation will be 8,100 if they stay in the cottage from Thursday to Saturday night. Verify showing all calculations whether a statement is valid. Okay. We look at this. If they took the 6 sleeper from Thursday, that means midweek. Midweek they pay, because they're going to pay for Thursday. Then Friday, Saturday. Thursday they pay 2,640. Money for, because here they say the rates given in the table are per cottage per night. So per night they pay this much. So how many nights will they be? These are 2, which is 2,700 at times 2. This is how much they would have paid. Now says that the total cost for accommodation will be either if they stay in cottage from Thursday to, they say the cottage, not cottages. So you can't use option, because option 1, if they stayed, there are 5 people. If 5 people are split in 2 sleeper, that means they will need 3 sleepers together, which means 1.15 times 3 plus 1205 times 3, which would be expensive. Why am I saying 3? Because the first one, it will take 2 people. Second one will take 2 people. The third one will take 1 person. So it becomes a little bit expensive. Here they will pay, okay. They will pay 7,200. Oh, sorry. This will be 2. This will be 2 times. So you see how the 2. Why am I multiplying by 2? Because we have Friday and Saturday. This is just Thursday. This will cater for. So the 2 sleeper couch is expensive. Okay, that's how we are showing it. And don't forget to conclude and say it's valid. Why am I concluding? Because they say verify, showing whether his statement is what? Valid. I need to conclude and say it's valid. Get 1 mark. So we can't use 2 sleeper. All right, 5.3. And next, just see the road, and it shows the toll gates. Indicate whether the following statements are true or false. If the false, give a reason. This is false. There are other toll gates on other roads. Let's look at the next, just see. Here we are. This is N3, you see. So we have also these other roads. N1 has toll gates. The T stands for toll gates. Then when you come also to the other side, which is the N17, it also has toll gates. M11 to M road has N2. It has a toll gate there. So it's not only on N, it's not on N3. N2 also has toll gates. You see that? Okay. So who is on the east of Lesotho? East of Lesotho. So you come to Lesotho here. You draw a small compass. So this is our north, east, west, and south. Take note. If the map does not have a compass, please, we shall always take the top part to be the north. So east, and the place you're looking at, it's this other side, which is true, true. So the answer then becomes true. Answer becomes true. State the view. State the view represented in the layout below. We shall say it's a road map. The distance from Johannesburg to Makosi, it's 888 kilometers. And the Land Rover covers this distance in 7 hours. Calculate the average speed of this vehicle. Calculate the average speed of this vehicle. Calculate the average speed of this vehicle. What are you going to do? You know very well, look at the formula they've given you, distance equals to speed times times, but you're looking for speed, so speed will equal to distance over time. Please always remember that. So our distance is already in kilometers. 588 divided by 7. So the average speed was 84 kilometers per hour. The accommodation, petrol, and toll gate fees for this round trip is cost and will be shared equally amongst all the group members. Calculate the total cost per person. You may use the price of your petrol, accommodation, and petrol and toll gate fees for the round trip. For the round simply means it's the same as what? Return trip. You go, you come back. So which values are we going to multiply twice? Because there are some values. For example, the toll gate, you go when you're going, you times by, you go, you pay, then as you come back, you also pay. The petrol fee, we need to find out how much they paid for petrol fee. That's times 2 also. Accommodation, it's once off. There's nothing much to do. So we're going to say accommodation, petrol, and toll gate. These we need to multiply by 2. This is once, because once you're there, you sleep once and you come back out. Okay, but before you pay for petrol, we need to know how much how much distance was covered. So we shall say, because we are going to use the fuel consumption rate, which is stated already here. The fuel consumption is 6 liters, 6.42 liters per 100 kilometers. Now, and if they will travel to and over the vehicle, the fuel consumption of this and the sitting layout. So we go and we say 6.42 liters for each 100 kilometers. Together, 6.42 liters for each 100 kilometers. But we need to know how much distance was covered. So here we shall say how much petrol shall we need. We shall take the distance covered, 588, divided by 100 times 6.42. I'm looking for the amount of liters. 588 divided by 100 times 6.42. We have it as 37.7496. Multiply this by 2. These are number of liters. We have 75.499. These are liters. We multiply by the money. How much I'm looking for the money for the fuel. How much we need to be for the fuel? So fuel only, we need to spend 1,600.68 cents. This is petrol plus accommodation, which is 8,100. Then we are going to add on the toll gates, which is 2 into, we are going to add these amounts here, 2 into 56 plus 77 plus 82 plus 58 plus 13.5. We are saying we are going to add all these values, which will be 56 plus 77 plus 82 plus 58 plus 13.5. How much are you paying for that? Here you would have paid 573 for everything here. So let's add fuel money, 1,615 rand 68 cents plus 8,100 plus the 573. So the amount, it's 10,288 rand 68 cents. So we divided this, because there were 5, we divide by 5, and each person has to pay 2,050 rands, 57 rands, 74 cents. 74 cents. And this will end our solution today. So all of them, when you look at them, they indicate a quarter to. So the best answer here is Z. All right. Name two time formats used to display time on the clocks. Now, as I told you, there are two of them. You either call it analog, which is the same as 12-hour system, or you can call it digital, which is the same as 24-hour what? System. All right. But you have to remember, in analog, this is where we have AM and PM. Here, we have nothing like that. However, when it's past afternoon, the hour you add on what? 12. But the morning hours, they will remain the same until past afternoon. They remain the same until noon. Then after that, you start adding on 12, 12, 12, 12. You get the answer to be displayed in digital. All right, write down in words the time displayed on clock B. Let's go to clock B. When you look at clock B, it's a digital already together, but they want to write it in words. I mean, in words, not in numbers. Let me write it down here for you to see what they're trying to say. This one, write it in words, is supposed to be a quarter to, a quarter to 1 p.m. Oh, you can say a quarter to 1. We didn't know whether it was morning or it was in digital form. Yeah, it's a quarter to 1, as in 1 p.m. Or you can say a quarter to 13 hours. All right, because from here we are expecting 13 hours. All right, write down the number of clocks that clearly indicate a time in the afternoon. Write down the number of clocks that clearly indicate a time in afternoon. Let's come here and you see clearly. So this is one of them. B, it's afternoon. Because if it was, because it's digital, in digital midnight, it would be 00:45. You see that? But now this one's clearly afternoon. Why? It's because it's in digital format. It was not supposed to be like this one. Also, it's another one. Clearly afternoon. Either for the analog we cannot use because we don't know where it is or what it is. Had they put AM, PM, then we would tell. But we are only looking at digital. So it's only B and E. Write down the number of clocks that clearly indicate a time in. Clearly. Take note of this, clearly. So we don't want to guess. If you use analog, you'll be guessing. So we said they said write down the number of clocks. So how many are they? There are only 2. In brackets, we said B and E. All right, please, you may pause and refer to the annexure. All right, let's continue and we see what's happening. Convert 16 hours, 45 minutes to minutes. convert 16 hours and 45 minutes to minutes. In other words, these are already hours. These are minutes. We don't need to change them. Why? Our main aim is to have minutes. So remember, these are 16 hours. We need them to become minutes. Yet 1 hour has 60 minutes. Simply meaning, get the 16, multiply by 60, get the 16, multiply by 60. We are fighting to say that they become minutes. So 16 times 60, you get 960 minutes plus 45. So all in all, we have the total number of minutes as 1005 minutes. 1005 minutes. Hours, they became minutes. Minutes, they're minutes. You can't change minutes to minutes. So you add everything together. We are continuing. Let's see that we go through this. All right. In paper 2, we shall be expecting measurements. Actually, you're looking at measurements and conversions. All right. And assembling of objects like we see here. Illustrated below are steps and some instructions to assemble a deck chair. To assemble the deck chair, the wooden pieces are joined together using fasteners, brackets, screws and bolts, washers and nuts. These are 32. Okay, there are 32 pieces in the packet of fasteners. Each bolt is secured by a nut and a washer. So anyway, it's fine. We should not overthink about it, but you understand. One bolt. The bolt is that nail that. So one bolt, it will have a washer. That small, there's a small disc-like material. Then with at the end, you put the nut together. So one bolt, this is a full set now. One bolt should have one washer and a nut. All right, for screws, you know the screws, you just screw and it fastens the wood. Go straight forward. All right, here we go. They are saying part A, it says, so the step 1 says attach the seat using bolts, which is B, nuts E, and washer D to the front, so to the 2 front legs. Attach the long, which is A. Then we go to step number 2, which says attach the arms to the 2 front legs using the bolt C, E, and D. So here we go. We have attach the back of the seat and the arms using the screws, which is A. Together. Then step number 4, it says short brush. Okay. Here we go. Use C. Determine the number of type C bolts used to assemble the deck chair. We are looking at C. The number of bolts. Determine the number of bolts. Okay, how are we going to determine them? Remember, they told us there are 32 pieces in the packet for fasteners, and each, remember they said these pieces of a chair are joined together and using fasteners, of which fasteners include screws, bolts, washers, and nuts. And they're telling us that in only one packet we have 32 pieces. So let's come down here. When we look at this, when we look at this bolt C, they are missing. Numbers are missing here. So in other words, we need to know when I add my 8 screws plus my 6 bolts plus my type C bolts, which are not there, I will leave it as C, plus my D, which is 8 washers, plus E, which are 8 nuts. I should get the answer as 32. Where am I getting 32 from? From the scenario. A pack consists of 32 pieces. All right, when we add this very well, we shall end up saying that the answer that we have is 14 plus 8 is 22. 22 plus 8, you get 30, which is this means this simply means we have got 30 bolts plus C should give us what? Should give us 32. All right. So having done that, but when you add 30 plus C, what you get 32. So meaning our C is supposed to be 2. Our C is supposed to be 32. All right, state the number of nuts left over after step 1 is complete. Step 1, let me see. Step 1, what does it need? Step number 1 needs attach the set using bolt B. Bolt B, nut E, and washer D to the 2 legs. So here we are. Let me see. And the A, but they're saying here, the question asks us, state the number of nuts left after step 1. Step 1, how many nuts does it need? You understand? We have the type E nuts, but how many of them? We shall have, let me see here, we have E again. We shall have 6 nuts. 6 nuts, because here we are. We have, let me see. Attach the set. They never told us how many nuts are inside here, but anyway, we shall take it to be here. You take E, 1 E. Also, this other side you take E. So of the 8, you've taken off 2, because of these 8 nuts, you've taken off 2. So how many do you remain with? 6. 6 what? Nuts. Name the last piece required to complete the assembly of the chair. It was already named here. The last piece it's this A. This part here. The short brass. So short brass. All right. 1.3. We have a map here that we need to look at and analyze. All right. They're telling identify the type of scale used. The scale is this one, which is here. Together. This one, whoever said a bar graph, a bar scale, sorry. Whoever says a bar scale, my friend, you're right. No, any other? Guys, please refrain from guessing. Find someone saying a map scale because it's on a map. No, it's called a bar scale. Also, someone who says a line scale to be fine, but the right answer is supposed to be a bar scale. Name the province that lies east of Northwest. Remember, the map, what is it about? Or what is it for? It's for the Northwest. Yes, so definitely, Northwest cannot be east of Northwest. You understand? So they are saying, name the province that lies east of Northwest. East of Northwest. So first and foremost, look for a compass. If it has no compass, we take it by the compass is here. Simply meaning it's like this now. The campus. This is the campus now. So we have north, south. This side becomes what? East, and this is what? West. So we come here. So we are supposed to look on this side here. East of north, west. So here I say Gauteng. This is Gauteng, but then this is east. What about north? Because this, if this is north, northwest, and we are looking for that lies. They said the province that lies east of northwest province, east. So we shall say it's what? Gauteng. It's directly there. It's Gauteng. Gauteng lies east of northwest. All right. Identify the national roads that passes through Freiburg. First and foremost, identify the place. This is it. This is Freiburg. So we look for national roads. We have N14. It comes here, it continues as N14. Here we have N17. N17, which is this, N14. It's around what? Freiburg. All right, those are the steps that we see. So they pass through. So they said, identify the national roads that pass through Freiburg. So we say N14 and N17, as we saw it on the map. All right, I'll write down the number of destination towns / cities shown on the map. There's a number of destination towns / cities shown on the map. Now, if you don't know that, most questions they have a key together. So they're saying write down the number. They didn't say mention, but they said write down the number of towns / cities. So what we're going to do, whatever word we find in this box like this, you just know it's a destination town or city. So here I have my friend 1, the other one's called 2. We have 3. Come down here, count that 4. We have 5, 6. We have 7. All right, someone might think of Pretoria. No, yes, it's there, we see it, but it's not in that box. Together. Another thing, someone might think of the N4s and the N. No, these are roads. They are not destination what? Towns. So we have 7 destination towns / cities. 7 destination towns or cities. That's it. Okay, here we go. Unfortunately or fortunately, we are not using any ruler. But if they say measure in millimeters, my friend, here, this is when you pick your ruler. Pick your ruler. When you pick your ruler, please you measure the distance as they have told you. Now, in brackets, I've said as the crow flies. So in simple terms, here, they don't want you to use the string or the thread. Here, use a ruler and it will be a straight what? A straight line from one point to another. Now here they're saying as the crow flies from Blue Mouth to Lichtenberg. Together. So you come here, identify the towns. We are here. Together. Then we are going to Lichtenberg, which is this one here. The place is here. Ne? So put your ruler here up to here. Measure the distance that you get. Measure the distance that you get. Measure the distance that you get. So now what you're going to do, hello? What you do now, it's I'm going to just show you here something small. All right, you get your ruler, then you measure from this distance here in a ruler, please, with a ruler, sorry. You measure it from this place to this place. So let's imagine you have approximately, they said measure in millimeters. So you write it, approximately you have 12 millimeters. Yeah? So you come here down. No, this is too much. It's not it's probably let's say you have 50. If you've got here 50 millimeters, you come down here and you measure it. Just write and you say 50 millimeters. You use your ruler there, please. All right. Let's look at question number 2. Question number 2. Question number 2 talks of the annexure. Get it, please. What we see, it's what they want us to look at. So we are looking at question number 2.1, annexure A, which is 2.1. All right, it talks about seating plan, I believe, and as you show it, as you see it, annexure A shows a restaurant seating plan for customers. Use the information on annexure A, answer the following questions. Give one possible reason why this restaurant has so many windows. One possible reason. This is simple. Number 1, to have fresh air. You understand? We need fresh air, air circulation, air flow. Number 2, to have enough what? Enough natural light. You understand? And if you have enough natural light, guess what happens? You don't need to switch on the lights. In the end, you cut on electricity. All right. Someone might have other reasons, like for easy fire for example, in case of fire incidences, it's easy for customers to exit instead of them using one small exit. Others can jump over the windows and an easy way of escaping. All right, calculate the maximum number of chairs available for customers. Let's go to our next chair. The next chair is here, and numbers available for customers. Please take note. How many tables have 4? We have 1. We have 1, 2, 3, 4, 5, 6, 7. So this, remember, we're looking for the maximum number of chairs. So only these ones that I've ticked now, they are 7 tables, but each has 4 chairs. So those are 28 chairs. Keep them aside, please. Let's continue. How many tables have 1, 1? So we have 1, 2, 3, 4, 5, 6. So these are 6 what? Plus 6. We are going to add on. How many tables have 2? 2. It's only 1. So plus 2. Plus, how many tables have 3? We have 1, 2, 3, 4, 5. So it's 5 tables with 3 chairs. How many chairs are they altogether? 15. So what? 15 chairs. Plus, what's missing here? What haven't you ticked so far? We talked of chairs. We cannot count couch. All right? We're only looking at chairs. So here, the table number 18 has how many chairs? It has 6. together. So table number 18 is the last one. All right. Someone might have seen the number of tables 21. You get 21 and say, there are 21 chairs. No, we are counting chairs that are available, maximum number of chairs. So you've seen it's 28 plus 6. I think 28 plus 6 plus 2 6 plus 2 plus 15 plus 16 plus 6, sorry, plus 2 plus 15 plus 2 plus 6. No, there's none of that. It's just like this. So 28 plus 2, 30. 36 plus, because I say 20, then here only it's 36. 36 plus 15 plus 6, you get 57. So we have 57 seats available for customers. 57 chairs, by the way. Determine the number of seats directly facing the wall on the south side. Let's go back to our next chart. So if you hear south side, so first and foremost, look for the campus. Together, the campus is not there, but they have given you here the main entrance doors are on the south side of the building. So definitely you have to look for the main entrance. So if the main entrance is here, so you're looking for chairs that are facing the south. Here we shall count them critically, or let's go and take note of the question. They are saying, name the number of seats that directly face the wall, the south side, directly face. Here we shall have, I think, 2 answers. Directly, so we have 1, 2, 3, 4, 5, 6. Yes, 6 what? Chairs. 6 would be okay. 6 seats. Or you say 6 plus. I'm going to show you something small here. This is facing the south hall. This is facing. Come to this one here. Come to this one here. Another one. Look at this one. What about this one? You see that? So we have 1, 2, 3, 4, 5, 6, 7. They are all facing the south. The south directly. Not because these ones can't, but this is diagonal. We can't count these, but these ones are directly facing. So we can say 1, 2, 1, 2, 3, 4, 5, 6, 7. So I believe also that one who says 13 chairs, it's to be fine because we are adding all those 7. All right, let's give one reason why the restaurant has couches at the entrance. Definitely now the couches will be used by those ones who are waiting for takeaways, I believe. You see that? Not for customers who are waiting for their orders to stand in the queue. You know, it confuses. For example, if you go to KFC and you find people waiting to collect, there will be also lining, as well as those ones waiting to order. So it confuses a little bit. But if someone is waiting for an order, let them have a seat. Then you know what? I'm left with these ones to serve. So the couch are for those ones who are waiting to take their orders. Give one reason why a restaurant has couches. Give a reason why a restaurant has couches. So here we go. 2.1.5. A person at the table 18 leaves her seat and walks towards her friend at table 4. She uses arrows. She uses the arrow path shown on the seating plan. Use the compass direction to describe use the compass direction to describe the path from table 18 to table 4. Use the... Now, when you hear compass direction, what comes in your head? You need to mention north, you need to mention east, you need to mention west, you need to mention south. At the end, you're looking for news. Are together? So let's go there and we see table 18 is heading to table 18 is heading to table 4. Table 18 is heading to table 4. Let's go and check on their next year. And next year, and next year. Let's look at their next year. All right, the person is in table 18 here. But okay, the person is going to use, they said use the arrow direction. At the end, they are also using the compass. So the compass, remember, this is north. So this is what? South. Why am I saying that? Because it told me the main entrance is found at the south of the building. So the person, table 18, they will move in the southern direction because they need to move like this. They're saying describe. They move southern direction. You move in the southern direction, or you move south towards table 7, pass table 7, then turn east. Turn east. Turn east. Having if you turn east, the third table on your left, that will be the person, because this is table 4. Person is coming from table 18. So south and east. Right? But if at all they are not said, use the compass direction, this would be the person stands up, he moves towards table 7, he moves towards table 7 here, which direction is that? We can't, it's straightforward. Because if a person was seated here, he definitely has to leave the table, come onto this line, then he moves down. As he's moving down now, this is his right and this is his left. For you, this is your left and this is your right. But for him, his left would be here, his right would. So he will come here. So he will turn left after table 7. Then the person will be on the right-hand side after turning. All right. Let's continue. We look at question number. Norm claims that there are less than 21 tables for customers in this restaurant. State a reason why, whether her claim is valid. All right, let's go and we say a next year. Let's see if they are less than 21. Indeed, they are less than. Let me see. I'm going to count them. So we have 1, 2, 3, 4, 5, 6. Yes, these are 6 tables. 7, 8, 9, 10. Yes, 10 tables. 11, 12. Yeah, 13 is missing. 13 is missing. 14, 15, 16. 16. 17 is there, 18 is there, 19, 20, 21. Yes, there are 20. 13 is missing. There's no 13. Together? So we say there are 20 tables because the 13th table is not there. The 13th table or table 13 is missing. Table 13 is missing. State the reason whether her claim is valid. It's valid. State with a reason why. State whether her statement is valid. Yes, there are 20 tables. The 13th table is what? Missing. It's not there. All right, let's look at the next chapter B. Look at the next chapter B. Next chapter B, probably when I look at it here, I see a tree diagram. A tree diagram. Why do I say tree diagram? This is probability. A tree diagram because I see options. One protein, chicken. You take one of the, all of these are proteins, but you take only one. Then one side order, vegetables or salads. That's you pick one. Dessert, it's either ice cream or pudding. You understand? So that's why I just look at it and I see that it is what? This is probability. And they're asking which type of diagram is illustrated on the next year B. Let's go to the next year B and we see. And next year B, here we go. All right, this is the next year B, and as I guessed, it's probability. The kind of diagram that we see here, it's called this is called a tree diagram. This is a tree diagram. These are the branches. These lines that you see, those are the branches. Together? By the way, we have no leaves and we have no stems, but these are the branches. We don't have roots. I think the roots would be these numbers that we see here. Anyway, look at this. As you see the table itself, as you see the diagram, the tree diagram. This represents the first chance, the second chance. Together? This is the second, first chance, sorry. It's this one here, because here we're supposed to also have a tree, as in it has to be coming. So this one is the first leg. This is the first leg. So this is the first leg whereby they had to come together. So here they need to come together like that. So that's how it is. So in case one is missing, for example, this one here, you will have to work backwards. For example, this, let me see, this is 2.2, 2.2a. They are missing. Anyway, we see that this combination was good from here. They began with a certain letter, which is F. So here it's supposed to have F. F, V, I. F, V, I. Let's come here. F, V, M. F, V, M. So F is supposed to be here. Let's guess. Someone give us the answer here. The answer here is supposed to be, now look at all these combinations under this. They all start with C. Definitely your answer is supposed to start with C, which is this one here. But it's at the last place here. So it's C, goes with S, and it ends with M. So C, S, M. That's supposed to be the answer. This is the tree diagram that we are looking at. That's how we get the combinations. Last example or last solution that I'm giving, Let me see, we have, for example, how did they get this? They took the B, wonderful. They took the V, wonderful. And they ended with M. So the branch went like that, then it collapsed like that. Are we there? That's how we answer. Please never leave such a question unanswered. All right. We consider them to be free marks. We continue the other question. You see, what other question are they saying? We've already completed this. They're saying, name the type of diagram illustrated in annexure B. I've already told you it's called the tree. The tree is called the tree diagram. Write down the missing outcomes. We've already seen them from the annexure, which were A is CSM, A, CSM, and the B was F, fish. Say the number of combinations with beef as proteins. These ones are 4. There are 4 combinations. Let's go back to the next one. You see beef, which is B. It has split here, and look at where do you see B only? So you have 1, 2, 3, 4. So these are the 4. These are the 4 combinations that we have. The other question has to be, or it was, determine as a percentage the probability of randomly selecting a meal with pudding as a dessert. Now, what we're going to do, this is the sample. So probability will always equal to sample over the population. Sample over the population. Now, what's the population? The total outcome, the chances. Together? Then a sample, part of the population. Many of you have gone to supermarkets and you have seen that they're giving you, they will tell you that these are samples, simply meaning it's not a full pack, it's not a full package. They give you something small. So a sample is part of the population. All right, let's go there and we see. The sample you're looking for, it's the M. Together? But out of what? How many outcomes do we have? Here we have 4 of them. Here we have 4 outcomes. Here we have 4. Also here we have 4 out. I'm counting these outcomes here. Are they? Then having counted these outcomes, so all in all they are 12. So population, my population is 12. Of these 12 chances, how many combinations have M? How many combinations have M? I'll start with this one. This one has M1. This one has M2. This has M3. This has M4. This has M5. This has M6. So out of the 12, we have 6 chances that someone of picking someone who has taken OD. So we shall say it's 6 out of 12. They say determine as a percentage. So what we do, we multiply by 100. But I'm here seeing 6 over 12 times 100. Your answer, it will become 50%. Why did I multiply by 100? They asked me to determine probability as a percentage. And I went ahead, I used the probability method, which is sample over population. But because they need a percentage, I multiply by 100. Out of my 12 chances, I have 6, which I'm sure of. Over 12 that are all the ones, and I multiply by 100, I end up having 50%. 2.3. Below is a simple route map of Los Angeles Marathon, LM, in the United States of America. LM, it's 26,2 miles. All right. By the way, the moment I heard of America, guess what came in my, remember we have two systems of measurements. Ne? We have the metric and we have what we call the imperial. The metric, it's what you use in South Africa, kilometer, meter. We go to centimeter and millimeters. Whereas imperial, we'll start looking at miles. After miles, we look at yards. After yards, we look at what we call feet. And we shall look at inches. This is imperial. Together, let's keep that in our heads. For metric, they'll always ask you to provide the values, but for imperial, they will always give you the conversion factor. Anyway, keep this in your head, 26,2 miles. Okay, here we go. They say explain the meaning of the route map. This is straightforward as you look at it. The route map only shows, or it shows the way people who are running will follow. You understand? Route. Which route are you going to take? Together? Remember, this is a marathon. A marathon whereby people run in big numbers over a long distance. Together? Marathon, we also have what we call the cross country. I think the cross country is in the countryside. Right? Whereas a marathon, even marathons, I also can. No, cross country is a longer one. Anyway, map not on scale, simply meaning their measurements are not perfect that much. All right. Describe what's meant by the map not on scale. Together? In simple terms, it's not actual. Understand? The measurements are not actual. It's not on scale. Runners in Elson Marathon have passed the underneath a bridge at a certain point during the marathon. Explain how this is indicated on the map route with no route line. What do I mean? Take note here. There's nothing there. Even here, so simply means they are passing under the bridge. Even here. You understand? Here, they pass under. That's why the route is not indicated. As you here, you see it's clear. But here, it's under. That's how it's indicated. Come here, it's under. Come here, it's under. Also here, it's under. That's how we know that this guy is passed under the. Then this one here would be like a subway. Or a subway, what do you call it? A tunnel. Or lanes. Anyway, let's go and see. Write down the number of times that runners who completed the marathon will pass underneath a bridge. So that I was looking at. I said, how many times? So let's count this as 1. We come to this, we call it 2. Come to this one here, 3. And this one, we have it as 4. Any other part where the marathoners it's not clear. Probably 5 is something here because this is a start. This is an arrow. There's nothing there. So we go on and you see 5. There's no any other place. All right, this is 5. 5 times. Write down the general direction in which runners will face when they start in Flower Street. Now, when we look at general direction, please take note, general direction, you are not describing any route. General direction, what has to come in your head, it's the compass direction. Some people call it compass. Together? The compass direction, the north, east, west, and the south. That's what we're looking at. So let's go there and we see they said, write down the general direction in which runners will face when they start running. Now, before you give the general direction, you have to look for the compass. Now, here the compass points at this side. Look at the end. So simply meaning up there. So this side is what? East. This side is west. South. On top here, it's what? North. Together. So where are they facing? You come here. Try to draw the compass and look at where they are facing. South, west. South, west. Avoid writing shortcuts, but you should write it in full. All right. Question number 3. Here we go. These are measurements. Look at measurements. We look at area, perimeter, volume, surface area. Okay, that's wasting a lot of time. Let's look at this. Let's analyze actually the box and we see. Every learner in a technology class is expected to have pre-stick and pretty glue sticks. The pretty is packed in a rectangular box, sleeve, and the pretty is in a cylindrical container. So here we go. Rectangular shape. Here we are looking at the, so we have 2 shapes here. 1, rectangular. 2, cylindrical. All right. The dimensions of the rectangular face of the pretty sleeve are, and the cylindrical pretty containers are given below. All right. Pre-stick and pretty glue stick. Together. This is called a glue stick. The people call it pretty. All right, and we go on. Okay. We have definitely for a rectangle, you expect to have length, which is L, width, which is W. Most cases, we also need height. If it's a 3D together. Then a cylindrical, we only need the diameter and the height. This is already 3D. There's nothing much that you need to do. All right, there we go. It's calculate the perimeter of the front of the pre-stick. Number 1, pre-stick sleeve. So it's this one here. So the perimeter. So simply meaning, what's perimeter? Perimeter is the total distance around a given shape. And they've given the formula. Please, once they're given the formula and you indeed know that's the right formula, just continue, substitute in it. So we shall start with a 2 times, open brackets, length, 239, plus width, which is what? 89. Make sure that all of them are in the same units. So they are all in the same units. I need to go ahead. So having done that, your final answer becomes, don't forget the units, 656 millimeters. Millimeters. Okay, here we go. They tell us to calculate in centimeters. Take note of that. Calculate in centimeters the height of the opening / the closing part of the pretty container. We come and we see it here and we see, look at that. Look at that. This has parts together. Oh, the cap, yeah. The cover. The height of the opening / the closing part of, so it's the bottom part, this one which is dark here. So we need to know. Okay, they're saying calculate the height. Oh, okay, it's so simple. So what is going to be, look at this. So simply meaning, when from here up to there, let me call it O. No, Q. Let me call it Q. When because I don't know this, I'm calling it Q because I don't know it. From there up to there, it's Q. So when I add my Q plus my 7 plus my 2,5 centimeters, I should end up having 114 millimeters. But look at this. These are centimeters. Also, this has to be in centimeters. But these are millimeters. What you're going to do, you're going to change the millimeters to centimeters. So I need to change my 114 millimeters. I need to change it to centimeters. How do you change millimeters to centimeters? I will need to divide by 10. I'll need to divide by 10. So here I end up having 11,4 centimeters. I've changed this, but it's not the end. So we are saying when I get my unknown number plus my 7 plus my 2,5 They should give me 11,14. All right. So here, when I add this, I end up having my Q plus 9,5 equals to 11,4. But I'm looking for the Q. Which number do I add to 9,5? I get 11,4. So my Q now become 11,4 minus 9,5. 11,4 minus 9,5. I end up having my answer as 1,9. We said we shall take the total height the total height has to change to centimeters because they need my answer to be in centimeters. The total height, which is 114, we shall divide it by 10, get 1,4. So when we add these other areas, they should give us this. When I add my unknown, add plus 7, plus the 2,5, I should get 11,4. Simply meaning this has to be 7 plus 2,5 plus the unknown. When I add these two, I end up having 9, I end up having 9,5. So I will say 11,4 minus 9,5 equals to Q. Equals to, please take note of that, centimeters. The actual height of the glue in the P.2 container is 8,5 centimeters, and the volume of the glue rounded to 30 decimal place is this much centimeters cubed. Show by calculation that the volume of the glue was calculated if the diameter of the glue is 28 millimeters. The actual height of the glue so the glue inside the container is 8,5 centimeters, and the volume of the glue rounded to 3 decimal places, it's this much. So we need to show that the diameter is this much. But look at the formula they used. You understand? But in your head, because you're determining the diameter, you know very well that diameter is got from you getting the radius and multiplying it by 2. Together. So you're going to use this formula, you're going to use these values here. And the volume and the height of the glue and the formula to get the radius together. So this will be my volume, yes, which is 52,346 equals to 3,142. Do we know the radius? No, but allow me leave it as r squared times, do you know the height? They told us it's 8,5. So we multiply the normal numbers and leave the r squared alone, which is 3,142 times 8,5. You get 26,707. Please, I will leave the number the way it is. I won't round off. Let me do it from here. This is part B. Volume equals to pi r squared h. Remember, they've given us the volume already. The volume was given to us as 52,346. So 52,346 equals, when you multiply the pi and this number here with the height, and having 26,70 times the r squared, because the r is missing. So what do? I need to divide through by, there's a comma here. I need to divide through by 26,77 on both sides. On both sides, so it becomes 5,346 divided by 20. So when I do that, this will die with that. So I remain with my r squared equals to 1,96. So what do? I need to look for the radius, which become the square root of this, square root of my answer. Yes, indeed, I remained with r equals to 1,14. But remember, we are not interested in r, but r will help us get the diameter. What do? Multiply by 2 and times 2. So I end up having, these are centimeters. The proving is in millimeters. I need to multiply by 10. Indeed, I've done it. So this was the answer. This is part A. Part A. Looking for the diameter. What I would advise you to do, let's look at this. Volume of a cylinder will always be pi r squared. So this, we can put it in the triangle like this. Volume equals to pi r squared h. So if I'm looking for, definitely pi is a constant number, there's nothing much there. So if I'm looking for h, height, it will be height, yes. What am I remaining with? I'm remaining with volume divided by pi r squared. So simply meaning, if I'm looking for height only, what am I? I'm remaining with this. So which will be radius squared equals to volume. Whereas if you're looking for height, it's volume divided by pi r squared. So definitely, if you're looking for volume itself, it's the bottom part, all of it. That's how we remember those. That's how we remember the formula. Okay, we look at the second question. It says, determine and round it to the nearest gram mass of the glue in the P.2 container if the density of glue is 0. So density here, they have told us that density, the formula is here, density equals to mass divided by volume. So we determine the round up to the nearest gram, the mass of. So we're determining mass. Mass simply meaning it will be density times what? Times volume, which will be density, they have already told us is 0.82 times the volume of the glue, which is already what? So the mass, they said it's 442,92 grams, but they said round off to the nearest. Take note of this. So here it's 93 what? Grams. Why did I multiply? Because this one here, in actual sense, it's density equals to mass over volume. You are interested in mass. What happens? M will remain and the D will multiply with the V. Get answered. Mathematical literacy, conversions, and time. We shall look at this. So for question number 1, we shall start with this chart here that we see. The weather chart below shows different weather patterns for a week. Study the chart and answer the questions that follow, or the following questions. Forecast for Polokwane, represented by Polokwane district. Right, today, when you look at this, when you take a look at this, which day do you think it was this? It has to be a Monday. Why? Monday is the only day that's not showing here. So it's Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, Sunday. Anyway, here we go. This is when it was taken, sunrise, and right, detailed forecast for Polokwane represents by. Okay. They ask us which unit of measurement is used to express temperature in South Africa. Remember, we have two types of temperature. One is Fahrenheit. One is Fahrenheit, and the other is what? So these are degrees. So one is metric. So we use this. This is the metric one, and this comes from what we call the imperial. This is under conversions. Imperial, when we look at the measurements in the olden days, so yards, feet, inches, that's imperial. And we look at metric, we look at kilometers, meters, centimeters. So here we are looking at, it says the unit of measurement, we shall say degrees Celsius, so you can write it in full. Degrees Celsius. Write down the days write down the days with the model maximum temperature. Model, number that appears most, way, maximum. So this is the maximum temperature. Which days have the, so when you look at 21, 29, 26, 29, 29 has appeared twice. So it's the mod there, 27, 22, 20. So which days are these? All right. If this was Monday, then you have Tuesday, Wednesday, Thursday, Friday, Saturday, and Sunday. So which one? Okay, allow me come back here. Look at that. So it's Tuesday and Thursday. So the 2 days that we have a model number. It's Tuesday and Thursday, according to this chart here. Calculate the range of temperature on Friday. When we look at range, what comes in our head? Range will always be the highest value minus the lowest value. So simply meaning we shall take the maximum temperature minus the minimum temperature. So what's the minimum and what's the maximum temperatures on Friday? Let's go there and we see. Now these are the maximum temperatures that we have, and these are the minimum temperatures that we have on Friday. On Friday, we had 27 as maximum and minimum as 7. All right, then we shall come down here. We shall write 27 minus 7. So your answer becomes 20 degrees Celsius. That's the range. That's the range. All right. 1.1.4. Convert 29 degrees Celsius to Fahrenheit. Round off your answer to the nearest degree Fahrenheit. Guys, the moment you see that there is a formula, all you do, you try to substitute into your formula, right? The formula says Fahrenheit. The formula is for Fahrenheit. We are converting to Fahrenheit, which is okay. We don't need to substitute. Meaning, we need to where you see the C, you put the given temperature. Okay, the rest are okay. So here, open your brackets. 29 times 1,8 into. You understand? You close the brackets and you put everything. Now, when we multiply the 29 times 1,8, you have 52.2 plus 32. The answer became 84.2. But take note, they said to the nearest degree Fahrenheit. So simply meaning we don't need the decimals. So here the answer is supposed to be 84 degrees Fahrenheit. All right. We'll look at question number 1.2. 1.2 it looks at different kind of foods that we have here, provided by, I don't know, it's a Thundereduc. Let's read here and you see. Thundereduc is a member of a stockfellow group who resides 47.5 kilometers away from the nearest supermarket. Below is this description of items they frequently buy for their stockfellow. All right. We have Tastic 10 kg rice, that much. We have 50 kg of Samp, then we have 150 grams of Lucky Star Pilchard. Okay, that's what you usually buy. So now we here 1.2, 1.2.1, they ask you to change kilograms to grams. Remember, we have kilograms. We want them to become grams, or they should become what? Milligrams. But in between these two, we have 1,000. Also in between these two, we have 1,000. Don't forget, big to small, you divide, whereas big to small, multiply. Big to small, multiply. Whereas small to big, you need to divide. You need to remember, we are saying big to small, multiply, whereas small to big, you need to divide. Small to big, you need to divide. Anyway, so we are in between these two, kilogram to gram. So we are heading to the right-hand side, simply meaning we are going from big to small. Big to small. Because a gram is smaller than a, so we need to multiply by what? By 1,000. So you come here, you take that, multiply by 1,000, and the answer became 5,000 grams. You may not write the word grams, but grams, you write the G. 1.2.2, Thundereduc loves to give food to the less fortunate in small quantities of 125 grams. Determine how many packets of 125 grams will Thundereduc be able to give or to get from one packet of 10 kg Tastic rice. What we're going to do, since we are going, so we ask ourselves, okay, he has 10 kg. But the packages or the small containers where he's going to pack, they cannot take 10 kg. He's going to pack the 10 kg into smaller packets of 125 grams. So the kg has to become grams before. You multiply by 1,000. You end up having 10,000. So these have become grams. So if you have 10,000 grams, you want to pack it in small packages of 125. What do? Divide by 125. What answer do you end up having? So 10,000 divided by 125 equals to 80. So this is 80 packets. You will have 80 packets. 1.2.3. Thundereduc stated that the return trip from the supermarket to her house is 105 kilometers. Verify if her claim is correct. What we're going to do, we shall need to go there and we see what is the distance from her house to the supermarket. Remember in the scenario that we had on top here, it says Thundereduc is a member of a stockfellow group who resides, who stays, who lives 47.5 kilograms away from the nearest supermarket. So let's come down. How are we going to verify that? This now, when you hear a return trip, that means to and fro, or going and coming back, return. So you're going to multiply by 2. So it's 4.7 kilometers. Multiply this by 2. You'll end up having an answer as 95. 95 what? So this is not equal to 105 kilometers. So the claim, they said verify if the claim is what? Correct. So you conclude and you say it is incorrect. It is incorrect. Tando will leave. Tando will leave home at 5 minutes to 8 to reach the supermarket at 8:20, 20 minutes past 8. Determine the speed at which she will be driving to the supermarket. Use the formula below. Yes, whenever you're given a formula, please understand, analyze it. Because now this one says, because now what am I looking for? Determine the speed. Oh, indeed, I'm looking for speed. So speed is in the right place. Then if I'm to look for speed, that means I am given distance and I have time. All right, what's my distance? Remember, she told us she lives 47.5 kilometers from the supermarket. So the distance is 40. I will not use this because this is to and fro. Here, she will leave home. Simply meaning going. They have not told us that she will return. Yes, she has to return because she won't sleep in the supermarket. But for this now, we look at this because she's just going. So what about the time? Now, time we need to know. How much will she spend on the road? So what simply meaning? The arrival time minus the departing time. When you subtract these two, you remain with 25. 25, these are what? And minutes. Remember, speed is in kilometers per hour. You see? So we change the minutes to hour. What do we do? We divide by 60. Divide by 60. Divided by 60. Whereby you get 0.4. I'll round off to 0.42. So this is time now. These are hours. So now our speed will be, sorry, the speed will be distance over time taken. Distance over time taken. We said distance 47.5 kilometers. Time was the arrival, which is 8:20, minus the time when they left. We ended up having 25. These are minutes. Change the 25 minutes to hours. You get the answer 0.42 hours. So come now and substitute distance. It's this much. Time, it's this much. So our speed will equal to 47.5, don't put the kilometers, divided by 4.2. 4.7 divided by 0.42. So the speed was 113, 10. Round off, please. answer. So this is the speed she'll be using. That is the speed she'll be using. The right answer. Express the amount of fatty cheese in ounce required for the salad for the above recipe. If 1 ounce 0, equals to that much. So for us, we have 200 grams. We need to divide that and we get the answer as that much. Okay. If you look at 1.3.2, if 10 tablespoons equal to 150 mils, determine how many liters of olive oil are required for the above recipe. So now, I wonder why they're asking for liters. Anyway, these are the liters. These are milliliters. You see? 10 spoons. So simply meaning one tablespoon will equal to divided by 10, which is 15 mil. So let's go to the recipe and we see. So the recipe says olive oil, we need 3 tablespoons. So we shall multiply this by 3. You end up having 45 mils. They don't want mils, they want liters. So of the mils, we divide by 1,000. The answer becomes 0.045 liters. Tando claims that she requires 100 grams of peanut for 9 people. Verify the calculations. First and foremost, remember that the preparation that you have is for 6 people. Now you need to look for how many or how much will the 9 people take for the peanuts. So we shall say 6 people. They need how much? 6 people need the peanuts. Where are they? The peanuts. Okay, yeah, it's supposed to be peanuts, not pine nuts. These ones here. For 6 people, we have 500 grams. So we shall say 6 people, 500 grams. What about the 9? Because we need to prove. Should it equal to 100, then the person is right. But if it's below or above, it's not right. Then here we go. All right, this becomes 50 times 9 divided by 6, which becomes so we need 75 is not the same as 100 grams. So it's invalid. Let's look at question number 2. And question number 2 has time. Definitely, if we look at time, we shall also look at what we call duration. We look at duration. All right. Mr. Van Veek works at OR Tambo International Airport, and he travels to work using the bus transport available in the location of Tembisa next to the hospital, and his transport uses the following timetable. Study the timetable and answer the questions based on the timetable. All right. This is the timetable when you look at it. The first section, actually there are 2. We have section 1 and we have another section. Now this is from Tembisa to OR Tambo, whereas this is OR Tambo to Tembisa. So simply meaning this is what he uses from here to work. Then this is from work to home. Right. Why? They've told us he works at OR Tambo. So he works there. Where does he stay? He stays next to Tembisa Hospital. So Tembisa to International Airport is going to work. Then from OR Tambo to Tembisa is coming back from work. Anyway, we have different sections here. We shall go on and see. These are ticket sales. Where are they sold? And open for ticket sales, close for ticket sales. So now opens for it closes the open, closes, open, closes. Anyway, let's continue and we see. Look at the questions. Identify the name of the bus company that Mr. Van uses to get work to work. Now this is adapted from City of Ikuleni Alambe Bus Services. So this is where the bus service is called Alambe Bus Services. Identify the ticket sales. Identify the ticket sale points that are convenient to Mr. Van Dijk. Remember, he is in Tembisa, so convenient. Let's come and look at the ticket sales. If he's in Tembisa, he can take from Tembisa Hospital, Tembisa main station. No, this one, no. Why? It does not stop here. It does not do anything here. Let's look at this one here. This one's not there. This one, no. This one, no. Yes, this one, yes. This is possible. Why? He leaves Tembisa, he goes to OR Tambo. So he can easily also buy tickets as he's coming where? Back home. You know, he reaches workplace, as he comes back, he can buy a ticket from there. Or from his workplace, from his home place, he can buy tickets. You understand? But the variable one, I think it will be Tembisa Hospital and OR, because here they say, okay, yeah, also when it's in Tembisa, it's fine, it will work also. So the points are, we have Tembisa Hospital, Tembisa Hospital, then we have Tembisa main station, and the OR Tambo. The OR Tambo, where he works, International Airport. Yeah, these are the places where he can get. These are the places where he can get tickets. What time format is used in the table? What time format is used in the table? Time format. Remember, we have two time formats. One is called the analog, and the other one is called the digital format. Here, analog, we call it the 12-hour. We call it the 12-hour system. And the digital, we call it the 24-hour system. I'm reminding you of this. All right. What happens under analog, we need to see. Under analog, we expect someone to have AM and PM. Whereas in digital format, there's nothing like that. No AM, no PM. So let's go on to our chart here. When you look at the time, it's fine. When we look at the time, we have no AM, we have no PM. And when you look at the evening or afternoon, there's no PM. The time has gone beyond 12. We have 13 hours, we have 14 hours here, 14 hours, 20 minutes, 15 hours, 20, So the time, the right answer here, it's digital. Why? There's no AM and there's no PM. So we shall say it is 24-hour format. Reason being, it has no AM or PM. On the table, it's not indicated anywhere. It's not indicated anywhere. All right, 2.1.4. Write down the arrival time of the bus that leaves OR Tambo International Airport at 22 hours 30 minutes. It leaves OR Tambo. It leaves OR Tambo. It leaves OR Tambo at 22 hours 30 minutes to Tembisa main station in 12-hour system. First and foremost, you want us to write the time of the bus that leaves OR Tambo it leaves OR Tambo at 22 hours 30 minutes to Tembisa main station in 12-hour format. So we need to look at that. We shall come here. Let's check their next step. So it leaves OR Tambo. We shall look at this one here, but it leaves at 22:30. So it definitely is here to the main station. So it leaves at this time. It arrives at this time. So they want us to write this time here. This is the time they want us to write this one here. They want it in 12-hour. They want it in 12-hour system. And remember, 12-hour system, we indicated we should end with either it was AM or PM. But when you look at it, it's 23 hours, 28 minutes. So in 12 hours, 23 represents 11. 28. But when? At night. It's PM. So the answer is supposed to be 11. Right? They're telling us the arrival time. Right? The arrival time of a bus that leaves OR Tambo at the same. So when does it reach this? We said there it reaches, okay, it leaves OR Tambo at 20. It departs from OR Tambo at 22 hours, 30 minutes. Then it arrives at 23:28. So this arrival time is supposed to be displayed in 12-hour system. So it reaches 11:28 p.m. Someone who doesn't know how we did this, we pick this time here minus 12. So we shall take 23. Shall take 23. It's 23. 28. Subtract 12 hours. Becomes 28 minus 0, you get 28. So here we have 23 minus this, you get here, there's a 1, there's a 1. So this is what, don't forget it was PM. That's how we get the time to be expressed in a 12-hour system. So if it's from 12-hour system to 24-hour system and it has passed afternoon, we add 12. If it's from 24-hour system to 12-hour system, we subtract 12 and we indicate PM. We subtract 12 and we indicate PM because it was already past afternoon. You understand? When we are changing 12 to 24-hour system, this happens when the time is in PM. 12-hour system to 24-hour system. We add 12 if the time in 12-hour system had what? PM. If it was AM, it remains. But PM, add 12 onto it, and you get, so the opposite is true. So from 24, it's already beyond 12, we subtract 12. Okay, calculate the duration of the bus that leaves the hospital at 7:30 p.m. to Aratambo. Express your answer as minutes. 1. We are looking at the bus that leaves the hospital at 7:30 p.m. When does it reach Aratambo? That's the first thing. How much time have you spent? So duration will always be the end time, which is the arrival time, minus the start time, which is the departing time. When does it depart? When does it arrive? So end minus start, arrival minus departure. Let's go to the table and we look at it. It's say the bus that leaves the hospital at 7:30 p.m. We go up there. But remember, the table leaves the hospital at 7. So the table, it will be perfect. Done. So it will give you the answer like this. Please, this is the answer. But then when you write it as 1 will represent the hour. 1 hour. Then this 15 represents the minutes. 15 what? Minutes. 15 minutes. So if you press the SD, it will give you it will give you 1,25. These are hours. Multiply by 60. The answer will become 75. This will be what? Minutes. Take note of that key there. We say duration, time taken to complete a given activity. And how do you get the duration? We said the time when the activity ended minus the time when the activity started. Now, in the case of the journey of the bus which you are taking, the arrival time minus the departure time or the departing time. So they are telling us the bus leaves. That means it departs. It departs. It leaves at this much time. By the way, you say calculate the duration of the bus that leaves and express your answer as what? So it leaves this time, much time, and it reaches this. So you need to know when does it reach. We went to the graph, picking the bus that leaves Tembisa at 7:30, which is this. When does it arrive at Aratambo? It reaches there at 8:45, which is 20 hours, 45 minutes. So we are looking for the duration. When does it reach there? So we said arrival is 20 hours, 45 minutes, minus 19. When you're dealing with duration, please make sure that you use 24-hour system. The time has to be in 24-hour system because it will be easier for you. All right? Okay, there we go. So this one here, it gave us the answer as 1 hour, 15 minutes. Since they want the answer in minutes, we say 1 hour has 60 minutes. We add on the 15 minutes because they're already 15, they are minutes. And the answer became 75 what? Minutes. 75 minutes. Then another method, you can do it this way. 20 or 45 minus 19, 30. What is it? 45 minus 15? Sorry, 45 minus 30, you get 15. And 20 minus 19, you have 15. So this represents hours. This represents, you do the same story, which is 60, representing the minutes from the hour, plus the 15, which are already minutes, which is what? 75 what? Minutes. Yes, the other one I said is a key that we use. You look onto your calculator there. Look onto your calculator, the scientific calculator. Look for the key. It's usually above English. Ing. It's not English, but it stands for engineering. So the key looks like this. It has a small or then sort of commas. Look for that key, please. How do we use it? We shall press 20, then you press the key. You press 45, you press that key. Minus, because we are subtracting. Minus 19, press the key, and you get 30. You press the, don't forget, press the equal signs. Your answer will come out as 1. One with the degree, then 15. It looks like feet, then 0. So this will be hours. These are minutes, and these are what? Seconds. But then you press the key again. No, you press from here. You press SD. This is a key. You know how to press the one that changes fractions to decimals. You understand? You press that key. It will give you 1,25. That's turned it into hours. Again, everything becomes hours. But you want it in minutes. What do? Multiply by 6. You will get your answer 75. This will be what? In minutes. The reason why I'm showing you all this is to get to see that how you get the perfect answer. All right. Let's look at question number 2.1.6. If Mr. Van finishes work at 17 hours, he finishes work at 17. Remember, he is in OR Tambo, so he has finished work at 17. Now, another thing that we have to put into logic, when you finish work at 17 hours, you can't get a bus immediately. Why? You need time to walk to go to the bus. You remember, you're not working in the station. You understand? So here we go. It says, catch, after he catches the second bus. Take note of that. He finishes work. He catches the second bus after work. It takes him 18 minutes to walk from the bus stop to his home. That's when he reaches at Tembisa. Calculate his arrival time at home. So he has finished work. He will go for the second. He goes for the second bus. You understand? Let's go and analyze that. He's from OR Tambo to Tembisa. So when you come to the chart here, we shall look for OR Tambo to Tembisa. So when does he finish work? He finishes work at, because this one here, it's in the morning, comes in the afternoon, and then comes, it goes into evening. So he has finished at 17 exactly. If he finishes at 7, he would have taken this, but you can't, because if you finish work at 17, definitely you're not at, yes, sir? For you to reach the bus station, maybe you take some minutes. Anyway, so he takes the second, they said the second bus. So he takes this one that leaves at 17:20. You see that? Now, he's going to Tembisa Hospital. So if he leaves at this time, you reach Tembisa Hospital at 18:34. After reaching Tembisa Hospital, that's his bus station, he will have to walk or to move from the station for 18 minutes. So he has left using the second bus. When does he arrive at Tembisa? He will arrive at 18:34 plus 18 minutes. Plus 18 minutes. So when will he arrive at his place? Let's go and do that. We are saying he takes the second bus, but the second bus leaves at 17:20. So it means after finishing work, he catches the second bus. So he used 20 minutes to go to he used less than 20 minutes to go to the bus station there to get the bus. Then this bus leaves. It has to go to Tembisa where he stays, and it arrives there at 18:30, 34. So if it reaches there 18:34, now this is at the station. He has to walk 18 minutes. We need to add them on. So this is 2, 12. So 1 plus 3 plus get 5. So it's what? So he reaches home at 8 minutes to 7. That's when he will arrive at his place. That's when he will arrive at his place. Question number 2.2. The rail transport is still convenient mode of transport in European countries. Below is the map that shows the routes and the duration of the train from different countries in Europe. Study the map and answer the questions that are based on it. Questions that follow. This is the map. Now, we see time. This is time. Time. In other words, this is duration, not time. That's time. So from Berlin to Frankfurt, it's 3 hours, 52 minutes. Same. From Frankfurt to Berlin, it's that much. Amsterdam to Berlin, it's 6 hours, 4 minutes. You understand? This is this town is this one here calling, but it doesn't show the time here. There's no duration. Anyway, we have time there between this and Brussels, Amsterdam and Brussels. It's 1 hour. London and Paris, it's 2 hours and 16 minutes. Ne? These are the durations as they talked about it. It shows the routes and the durations, how much time someone uses when they're traveling in between those routes. Anyway, let's go there. Define the term duration in the given context. Now, here the context. Now, the context that we're looking at, it's train traveling from one town to another. European, this in Europe. Ne? So we shall say duration, time spent traveling from one town to another. Duration, the time spent traveling from one town, one town to another. Duration in this context, it's duration here, we shall say duration is the time taken to travel from one town to another town. Another town. It's a duration. All we need to say travel or time taken by the train to travel from one, because we are looking at trains context. All right. when we look at the context thing part of it, we are looking at the what's going on. What are you looking at? What is in the story? How many minutes does it take for a train to travel from Milan to Rome? How many minutes? This I'm talking about how many minutes. So we go to the map, we look for Rome and Milan. Indeed, it's this. From there to here. They are telling us it's 2 hours, 48 minutes. 2 hours, 48 minutes. 2 hours, 48 minutes. So we shall say 2 hours, 48 minutes. So we shall say 2 hours, 48 minutes. These are minutes. You don't need to change them. So we change the hours to minutes. What do we do? 20 times 60. So 2 hours, we have 120 minutes plus the 48 minutes that I already spent. So the answer becomes 168. These are what? Minutes. These are minutes. 2.2.3. If the train leaves Barcelona to reach Paris at the time displayed on the clock alongside, at what time will this train arrive at Paris? Express your answer in 12-hour format. So now, hey, at what time will it reach? Now, another thing we need to know. They didn't tell us whether it was morning or afternoon. The train leaves Barcelona to reach Paris at the time displayed on the clock alongside. At what time will the train arrive at Paris? The train leaves Barcelona to reach Paris at the time displayed. To reach Paris at the time displayed. So if it's going to reach at, because you need to know what time is it. It's 10 past 10. Yes, and 10 past 10. This is when it's going to, because they say it leaves Barcelona to reach Paris at the time displayed. So it reaches Paris at the time displayed, which is so this is the arrival time. It arrives at this time. Then arrival time is that. Then at Paris, express your answer in 12-hour format. So we shall go and find out. Barcelona reaches. So from Barcelona to Paris, how much time is needed? Barcelona, it's here. Then Paris, it's there. How much time needed? 6 hours, 30 minutes. So we need to work backwards. We need to work backwards. We need to work backwards. Now, the problem is we don't know. It arrives at this time when 6 hours behind, 6 hours backwards. So we need to subtract. We shall subtract the duration time. 6 hours, 30 minutes. We need to because you're working backwards. We're working backwards. So it's 10 hours, 10 minutes minus 6 hours, 30 minutes. You'll see that time will the train arrive in Paris? Explain your answer in. Sorry for that. Let's look at this. If the train leaves Barcelona for Paris or to reach Paris at the time. So, okay, it leaves at the time displayed. So this is the departing time. You understand? On the clock. Then at what time will the train arrive at? So the simple meaning, it has not yet arrived in Paris. So what time will it arrive? So if it leaves at this time, which is 10 minutes past 10, we shall need to know how much time will it spend on the road? How much time will it spend traveling? So we shall go to the map and look for Paris and Barcelona. The map, Paris and Barcelona, it's this route here that you see. This route up to the, look at the time that it has. It has 6 hours, 30 minutes. So simply meaning, if it leaves at 10 that, so we shall come here and we add. So this is, so to express this time in 12-hour system, we shall say 1640 is the same as, remember we said we subtract what? 12. So this is 440 a train from Amsterdam to Berlin arrived at 0 hours 12 minutes. At what time did the train leave Amsterdam? So now we are looking for backwards. It leaves Amsterdam to Berlin and arrived at this much time. At what time did it leave? So what is the departing time? At what time did it depart? So we shall take the arrival time. Just remember, duration equals to end minus start. So we are going to have the duration here. So we are looking for what time did it start. So this will be the start time equals to duration. Sorry, end time, arrival minus start time will equal to end time minus the duration. So the end time, we have it as 0 minus what's our duration between Amsterdam and Berlin. We come here, look for Amsterdam is here to Berlin is 6 hours and 4 minutes. So we come and subtract. So this is 00, which is 24. Which is 24. So when we subtract this, it becomes 12 minus 4, you remain with 8. 24 minus 6, you remain with 18. So it left at that much time. Well, we said time has to be in 24 before you use it anyway. So we are saying the end time minus that time equals to duration. So we already have the duration as 6 hours 30 4 minutes. So that's the duration. So we substitute into the formula and we get the answer. Duration equals to end time minus the start time. So we are looking for start time. When did it leave Amsterdam? So start time will equal to end time minus duration. The duration, we already have it as 6 hours 4 minutes. The time when it arrived, or the end time, we have it as 0. This 0, replace it with 24 to make sense out of it. So you come here, you get your answer as, I've put the 0 here, put 24 minus 6. So 12 minus 4, you get 8. 24 minus 6, you get 18. So this is the time when it left. Two point 2.5. The distance between Lyon and Barcelona, between Lyon and Barcelona is 192 kilometers. The driver claims that if he leaves at 16 hours 40 minutes from Lyon, travels at a speed of 80 kilometers, he will arrive at Barcelona before the sunset. If its sunset in Europe sets at 18 hours 55, verify the claim. So in other words, what we're going to look at, first and foremost, we need to know how much is expected on the road. So for him, he says he's going to drive at it. So we shall know how much time is he going to spend on the road. So let's look at that, because we have the distance and we have the speed. That so we ask ourselves what will be the time. So using this formula here, first thing you need to do is to make time the subject, which will equal to distance over speed. So we have our distance 192, speed 80. When you divide that, we get 92 divided by 80. You've got the answer as 2, 2, 4. These are hours. These hours, you need to change them to hours and minutes. We need it to become hours and minutes. So we have 2 full hours and 0,4 times what? 60. I'm changing this 0,4 to minutes, which becomes 24. So he will spend 2 hours and 24 minutes. This is what he's going to spend on the road. All right. So we are aiming at him reaching the place at 16:55. So the distance. Okay. So now, if the driver claims that if the driver claims that if he leaves at this much, we'll reach there at this time, before this time. So we need to confirm. So if it's 16:40, it's going to spend 2 hours 24 minutes, which is what? This is a 60. So it becomes an hour this other side, and the answer became 19. So the claim is what? Invalid, because it does not beat the 18. Yes, it will be there around 9 minutes later. It will be there around 9 minutes later. Yeah. So his claim is invalid. One, in this question here that we had to look for how much time is he going to spend, plus the time he leaves, the departing time. Time spent plus the departing time. It should equal to 18. If it's not equal, then it's invalid. 2.3, we look at these kind of watches. Actually, these are wall clock, or yeah, they can also be wrist watches. Okay. Consider the clocks below. Okay, they are clocks. Which show different times during the day. That's afternoon, morning, afternoon and morning. Use the above clocks to answer the questions that follow. What time format is used in the above clocks? Explain why. Time format, we said is what? 12 hour, 12 hour system. Because it shows afternoon, and what? Morning. Someone else, remember we said duration equals to end time minus the starting time. You would say arrival minus departure. So arrival time is on clock A. Departing time is on clock B. Let's go and see clock A. Clock A, it talks of 12 to 6, 7, 8. 8 minutes past 12. Noon. And the B is 10 minutes to 2. 10 minutes to 2, which is 150. So it's 150 morning. So remember, we said we change everything to 20 before you subtract, because you know what you're going to do. What were you looking for? Duration, which is end time and start time. So you look for this end time. When did it arrive? When did it depart? So it arrived at 8 minutes past 12. You leave it a bit easy. If you change it to 24-hour system, this remains. Then 1 a.m. still also remains. So we subtract this. Now take note. 808 cannot subtract 50. What do? You borrow 1 from this other side. When you borrow, remember you're borrowing from hours, shifting them to minutes. So you've borrowed 60 minutes. So it becomes 68 minus 50. You remain with 18. So here you remember you took 1, which is 11 minus what? 1. So it becomes what? 10. So this was the duration they spent. So they spent 10 hours, 18 minutes. 10 hours, 18 minutes. 10 hours, 18 minutes. If they were driving at a speed of 80 kilometers per hour, how far did they travel? Round your answer, the nearest. So how far? Now, when we look at how far, and they have to round off to the nearest, so meaning we are looking for distance. And indeed, the formula they've given us distance equals to speed times time. So they've given us the speed as 8. Please, you substitute the same people. So times time. Now, the time has to be in hours. So it's 10, 18. This has to be divided by 60, which becomes what? 10 hours plus 18 divided by 60, 0, 3. So it's 10, these are the hours. So times 10, 3. So they spent how far? This is much, but they said round up to the nearest 10 kilometers. 10th, it's this one here. This one is 4, it's below 5. So the answer here becomes his wife claims that 2,500 will be enough for the return trip. The car's fuel consumption rate is 2.2 liters per 100 kilometers and costs. So and the fuel cost is 21 rands 50 cents per liter. Verify using the calculations whether her claim is valid. Now, what we're going to do, first and foremost, we look at what we call the return trip. Return trip simply meaning you're going to take the trip they covered times 2. So here we are. This is the distance that they have, because the scenario doesn't talk of the distance here. We don't know the distance, so we are continuing with whatever we have. We're still looking under the same. We are dealing with the same scenario here. Ne? So C, we look for the distance, and we are saying the distance is this much. That's only one trip, so it's multiplied by 2. Why I'm looking at the return? I'm looking for the return trip. So the distance covered here is 1,640. These are the kilometers. We are not interested in this. We're interested in how much fuel is needed. So we had to look for the distance covered. To and fro. That's much. Then we need to know how much fuel is needed. So we are going to use the fuel consumption, which is 2 liters per 100. So this simply means it will use 2.2 liters of fuel whenever it covers a distance of 100 kilometers. So it's going to cover a distance of 1,640 kilometers. How much fuel is it going to cover? We don't know. We leave it as a box. Cross multiply, and the answer became, I'm looking for the amount of fuel needed, and I will divide through by 100. So the fuel amount is 36,08. These are liters. These are liters. These are liters. So remember we are looking at the cost. So if they are going to use 36,80 liters, how much will it cost? So we shall multiply by 21 rands 50 cents. 21 rands 50 cents. So they will spend 775 rands 72 cents. So her claim is valid. The claim is valid. Had she said the wife claims that will be enough. Indeed, it will be enough, because that's what, actually, it's more than enough. But as she said that 2,500 will be the cost, then we shall say invalid. But here she said it will be enough. Indeed, it's enough. It's more than enough. So the claim is valid. Though she's going to use less than that. She's going to use less than that. Let's look at question number 3. Question number 3 looks at area, perimeter. As we go on, we shall be looking at area, perimeter, among others. All right. We'll go straight to question number 3. The picture below shows the dimensions of the rectangular vector garden with 2 gates. The garden has a length of 35 feet and 17 feet respectively. It has a length and a width of 35 feet and 17 feet respectively. Simply meaning the length is 35 feet and the width is 17 feet. In that order, respectively means in that order. All right. Note the width of the small gate. Okay, when you look at the garden, this is it. Those dots are poles that are going. This line they represent the round one represents a fence. Then these are the gates where one will enter from, and indeed this is a pathway where one goes through, and you go out from this other side. Okay. The width of the small gate is 9 meters, and while the width of the large gate is 18 meters. The garden will be fenced with a galvanized welded meshed wire. Study the diagram and the information above and answer the questions that follow. Question number 1, 30.1.1. Explain the term perimeter according to the given context. Now we shall say, remember, perimeter is the total distance around the given shape. And now we shall say the total distance covering not covering, total distance around the vegetable garden. Total distance around the vegetable garden. The total distance, you can see length around the vegetable garden. Vegetable garden. State whether the dimensions of the garden are in metric or imperial. Remember, metric is where we look at kilometers, meter, centimeter, millimeter. Now, imperial, we look at miles. Imperial, we look at miles. We have yards. We have feet. We have inches. So we go and we check on the garden. The dimensions, they are in feet. So your answer is what? The measurements here are imperial. Measurements there are imperial. Another thing that I've forgotten about the perimeter. Perimeter, it's when you start from here, you come there, you come there, you come here, again you go. So the distance that you move from here, you go like that, you add, you add. That's how we get the perimeter. When you move around a given shape of a given area, around, which means outside. Meaning it's the same as the space occupied by the fence or boundary. All right, a boundary around a given shape or area. Determine the ratio of the width of the smaller gate to the large gate. Remember, they gave us those measurements. They're here. But what I wanted you to know, first and foremost, know its ratio of the smaller gate and the larger gate. The smaller gate, what's the width? We come back to the scenario here. We have it at 0.9 meters, and the large gate is what? 1.8. In that order, please. 0.9 is to 1.8. Simplify it, become 1:2. 1:2. Calculate the perimeter of the rectangular vegetable garden in feet. You may use the formula below. Now, someone might ask us, shall we count the gate? Yes. Why? We are looking at the vegetable. We are not looking at the fencing, but we are looking at the perimeter of the garden. They are saying it's supposed to be in feet. Remember, length is 35 feet. And the width is the 17 feet. Substitute. So we shall say perimeter equals to 2 into 35 plus 17. We are looking at perimeter. Perimeter needs us to have length. It's already given to us at 35. These are feet. Then we also need to have the width, which is 17 feet. So we need to substitute, and we shall say perimeter equals to 2 into length plus width. I'm using this other part here, which is 2 into 35 plus 17. See that? So we go straight forward, and you see have the answer as 104. These are feet. So they are telling us, hence convert the perimeter of the garden to meters. So here we already have it as they are telling, if you only have 1 foot, you have an equivalence of 0.3048 meters. So for us, we have 104 feet. What would it be? We cross multiply. So the answer is to be telling us it has to be 3,16992. These are meters. In other words, this is 3, 31,70. All right. The roll of the mesh wire in the first roll in the meshed garden is sold in rolls of 120 millimeters. That's how long it is. But then the wire covers 10 meters. So 120 meters high and the length of 10 meters. So they're asking, determine the number of rolls of wire required to fence the rectangular. So before we do this, remember now this is when we are going to exclude, or this is when we are going to look at the gates. Why? Now you're bringing in the fence. Definitely you want to cover the face the gates. So what we're going to do, total perimeter of the fence. So we already got the answer there up there, which way we said it was 35. Added the 17. We got the answer as what? These were feet. We changed them to meters. And the answer we got it as what? 31,6992. Here, we shall subtract the length, the width of the small gate, which is 0,9. And we shall subtract this width of the smaller gate, which is that much. So remain with 28,9992. So these are the meters that we need. So we shall divide this by 10 because it's sold in 10 meters. So we divide that by 10. You see, you find yourself that you remain with 8,9992. But remember, these are rolls, so you cannot buy them in half. So if the person will buy 3 10-meter rolls. 3 of them, but the third one won't be fully used, but part of it will be used. They're asking, you can get the total cost of the machine wire face. That's so already we've seen it, that we need 3. 3 times 1,599. The answer that you get, equal to that much. Answer you get to equal to that much. Give one valid reason for putting a fence around the vegetable. And then the valid reason is known for the animals not to destroy the garden. You know, if you have animals at home, you protect them, you protect the vegetable garden from those animals. So by putting what? A fence, not to destroy the garden, the livestock, not to destroy the garden. Then the other one, what would it be? Also to be neat, protect your garden from intruders. Three 3.2, when you look at 3.2, almost the same part that we're looking at. And here we have this diagram here. Now this is from Mr. Malin intends to increase the area of his garden to plant more vegetables. The diagram below shows the dimensions of the existing garden and the alterations to the new garden. You understand? The existing is this blue one. Then these dotted ones are the extensions, which becomes the new garden. The garden has a circular garden bed with a diameter of 1,5 meters. Okay. Determine Mr. Malin's new length of the garden. Now you're taking the old plus the new one. So it's 11 plus 2. So the new length equals to the old plus the new. So we added that up. Take the area of the new garden in square meters. So the width is 6 meters and the new garden is 13. So let's go there and say our length is 13. The width is 6. And the answer becomes 78. The answer becomes 78. Don't forget these are meters what? Squared. You show the units because even there they said in meters squared. So please, you don't forget the units. These are just meters. They're not squared because just we are adding. Here it's a square because we've multiplied 2 times. We've multiplied the meter from here and another meter here. So we multiply the 2, you get meter squared. Here we're just adding. You don't get anything. It remains the way it is. We go to 3.2.3. Martin stated that the percentage increase in the area of the new garden is 40%. So how are we going to get this? Number one, we shall need, we need to know, because to get the percentage change, you need to get the new area. Allow me write it like this. Minus the old area. Everything divided by the old area times 100. Why? I'm looking for the percentage. Anyway, I have the new area. What about the old one? So I need to look for the old area, which will become L times what? B. Let's go back to the diagram. What's my old area? It's 11 by 5. So I'll come here, multiply 11 as length, 5 as width. And the answer becomes 55 meters what? Squared. So I have the old area. I'm good to go. I'm going to substitute. I'll say my new minus old divided by old times what? 100. The new is 78 minus 55, which is the old. I divide by 55 and multiply by 100. What answer do I end up having? 70 minus 23 divided by 55 times 100. So the answer here, you have it as 41.82%. So if you round it to, it's what they are saying is that the percentage increase. No, the answer is what? Invalid. Why? This is not 40%. Had he said it's 40, and it's above 45, it's 40%, then it would be valid. Why it's above? Had he said it's less, it would be false. Incorrect. All right, let's look at question number 3.2.4. Show by calculations that the area of the circular garden bed is 1,767375 meters what? Squared. Remember, we are looking at the circular garden. And indeed, they have given us the circle here. They have given us the area. The area needs the radius. And in the scenario, remember, they told us that it has the diameter. So how to get the radius? Radius equals to diameter divided by 2. They told us the diameter was 1,2. The answer becomes 0. You see, the diameter is 1,5. Sorry, not 2. So we do that. 1, divided by 2. We have the answer 0,7. Now our radius is 0,7. So we come substitute in the formula. squared. So 0,142 times 0,52 squared equals to 1,767375. 3 marks. Did you look for the radius? Yes. Did you substitute correctly? Yes. 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 Let's look at question number 4. We'll be looking at volume and surface area. This comes in paper 2. Mr. Msondo is a farmer in Vumakala. He sells milk. The milk is stored in cylindrical or spherical containers that are sold to customers in 2 liters, 5 liters, 10 liters, 20 liters, and 25 liters. Pictures of the milk containers are shown below. This is a cylindrical and this is a spherical one. Sphere, it's like a ball. Cylindrical, it's like a tin, a can of Coke, a tin of baked beans, the cylinder. Now, so this height here is for the cylinder, the radius is for the sphere. All right, let's continue. These are the formulas given to you, and you may use them, or you might need to use them. Use the information above to answer the questions that follow. They are saying convert this 770 millimeters to meters. So here we are converting millimeters to meters. Remember, we have this. So it's a combination. It's here. 1, between kilometer and a meter, we have 1,000. Between a meter and a centimeter, we have 100. And between centimeter and millimeter, we have a 10. So simply meaning, we need to change the millimeter to centimeter. Then we change it to meters. But when you look at it critically, you have tampered with approximately 1,000. When you look at it, it's 1,000. So what you're going to do, remember we said small to big, we need to divide, whereas big to small, we need to multiply. So we have from small to big, we're going to divide. Millimeters to centimeters to meters, we need to divide by 1,000. So we shall get the 770 divided by 1,000. The answer becomes 0.77 meters. All right. Determine the diameter of a spherical. Determine the diameter of a spherical milk container. As I showed you up here, the radius is for sphere and the height is for the cylinder. So remember, when we are looking for the diameter will equal to 2 times radius, which is the same as 2 times 2 times 73.5 and gives you the answer as 147 centimeters. 100. So define the term capacity. Capacity goes hand in hand with the volume, but capacity, we shall say, is the total amount of quantity a given container, can carry or contain. You understand? The total amount of quantity a given container can hold or carry. If not, you might say in this context now, it will be in this context now, it's going to be capacity is the amount of milk these containers can carry. Amount of the amount of the amount of the amount of milk these containers can carry. All right. That is it. Now they ask for volume. Actually, capacity in most cases, it will be in the normal form of liters, milliliters. We take example of your geyser at home. The capacity, its capacity is measured in liters. But when we are performing or when we are calculating this capacity, we need to have volume. So it's from volume that we get capacity. Volume is the normal one, the calculations in centimeters cube. You understand? The space a given object takes. All right, here we go. Calculate the volume in centimeters cube of the spherical container. What we are going to do, we go back to our formulas here. What are we looking for? Volume of a sphere. So here we are. We are going to use this one, which says 4 times pi times r cubed, volume. So, right, volume equals to 3,142. It orders times 4 times r cubed. All right, this is for a sphere. But we already know that the radius is already given, so it will be 4 times 3,142 times the radius that we already know as 73,5. It has to be cubed. What answer do you end up having? Let me do it here on my calculator. Have the answers. For 1,990,317,63 centimeters cubed. Centimeters cubed. Then we come to this. They say the capacity of the cylindrical container, is 60 liters. Determine the diameter of the container. Round off your answer to the nearest centimeter. Now, we need to ask ourselves, you well and good, they have capacity. And I told you its capacity comes from volume. So what we need to do is to change this capacity that we have, we change it back to volume. In this sense, because now they have told us centimeters. So it means we are going to change the liters to centimeters. You understand? Change the liters to centimeters. Then from here, 1 liter equals to 1,000 centimeters cubed. What about if you have 60 liters? What will it be? One liter 1 liter equals to 1,000 centimeters what? Cube. So if you have 60 liters, what will it be? Multiply by 1,000. So you have 60,000 centimeters cubed. This is now our volume in the normal sense of. I'm using centimeters cubed because I need my answer to become centimeters. I keep it aside. Then I ask myself, okay, if this is the volume, how did they get it? Remember, we are looking for the volume of a cylindrical container. In our heads, we know that already. Volume of a cylindrical container equals to pi r squared h. Do I have the volume? Yes, it's 60,000 centimeters cubed equals the pi is a normal number that we know. Times, what are we looking for? We are looking for the diameter. Do we have the diameter of the cylindrical container? No. So the reason why I'm looking for the diameter. So the reason why we are looking for the diameter, it's actually it's the question. So we don't have the radius. But it was not given. So we leave it as square radius what? Square times. We have the height. Remember with the height we said the height is 770 milliliters. Change it to the height. Let's change it to centimeters. It becomes divide by 10. You end up having 77 centimeters. This is the height. So I bring it here. So what I do, I take the normal number. 3,142 times 77 equals to 241,934. I will leave it like this. Times r squared should give us 60,000. I divide through by the same number on both sides. I divide through by the same number on both sides. It will die. Yeah, it will die. So I'm remaining with radius squared equals to, when I divide this other 60,000, I'll end up having, when I divide by 60,000, when I divide 60,000 by this number, I end up having 248,0015211. So on your calculator, because it's squared, I need to know what is r only. So it's because squared, I need to look for the square root on both sides. So I'll find the square root. So find the square root of the answer there. I end up having 15,74806.04. Now our radius is this much. I need to multiply by 2 because I'm looking for the diameter. So my diameter will become 31,96, which is approximate, because they said to the nearest centimeter. So we don't need the commas. So which is approximately 31 centimeter. When you look at this is 8 marks, and you ask yourself, how was it marked? Let's try to mark it and we see. Did you change the liters to centimeters cubed? Wonderful. Did you change from millimeters, the height? Did you change from millimeters to centimeters? Another mark. Did you understand this concept? 1 mark for that. Understanding this concept. Dividing, another mark. You applying the square root, 1 mark. Getting the right answer, 1 mark. Multiplying by 2, 1 mark. The final mark is here. Take note, whenever something is missing, whenever there's something that you find, you need to find, you need to show it, please. Right? For example, here you knew liters have to become centimeters cubed. That's a mark. You knew that the height is in millimeters, it has to become centimeters. That's another mark. You understand? That's a mark. Then you substituting to get the formula, knowing what is there. You would get a mark for that. All right, that's how it was marked. Let's go to the second question. Next question. 4.1.6. Determine the number of 1.5 liter containers that would be filled with the milk from the cylindrical tank or cylindrical container. Remember, the cylindrical container is worth 60 liters. Someone wants, it comes with 1.15 liter containers. How many shall we get from there? It becomes 60 divided by 1.5. You have 40. 1.5 liter what? 1.5 liter what? Containers. Okay, we look at this diagram 4.2. Let's look at it critically and we shall be. All right, this is a rectangular prism of which we know. Within what comes in your head when the moment you say a rectangular prism, if they ask for volume will always be. And if they ask for surface area, when it's closed, it will be 2 into L times B plus B times H plus L times what? H. If it's closed, but if it's open, it would depend on which side is open. It would depend on which side is open, then you have to manipulate it. All right? These are the formulas that I know I should remember when I look at a rectangular prism. All right. Mtondo makes a rectangular water troughs for his farm animals using concrete that is 5 centimeters thick. The diagram below shows the external dimensions of the rectangular trough with an open top. You see? So it's open. So this one here, if you were to look for the surface area, it simply means this side is closed. So it will be, let's say this is B, this is the height, and this is the length. So if this side is closed, so it will be B times the height, but these sides are 2 of them. So we shall multiply by 2 plus this side equals to so they are also closed. So it means it's 2 into L times what? Height plus this side, the bottom is closed, but the top is not there. So simply meaning it will be L times what? B. That's if they ask you for surface area of an open one. Why? The part here, it's missing, it's not there. Anyway, now we go on and you see these are the dimensions that we have. They are saying, wow, calculate the internal, use the diagram and the information to answer the questions that follow. The external dimensions are the external dimensions of the. So in most cases, when we look at this, definitely this has to be the length, right? And the height. In most cases, when you see it like, sometimes they will write it like, they will put the times sign. The times sign means by. If it's given this order, you also understand it's this other form here. But these are external, outer dimensions. So, calculate the internal dimensions of the trough in centimeters. Now, how are we going to get the internal? Remember, the dimension from outside, from here to there, it won't be the same as you measure from inside here to there. Why? There's a thickness. There's a wall that already has 5 centimeters. So if the dimensions are 5 centimeters thick, that means you're going to subtract 10 on both sides. You understand? For the length, you're going to subtract 10 because we have the 5 this side and the 5 that side. The breadth is same story. You need to subtract the 10 here, 5 that side, 5 this side. The height, you only need to subtract 5. The bottom part is representing, because the top one is nothing much. There's nothing here. All right, let's go and see. So we say the length will be 300 minus the 5 centimeter on one side minus another 5 centimeter, which will be 290. We go to the breadth, which is 190 centimeters. Also, you subtract 5 on one side, another 5 on the other side. So you remain with 180. Don't forget these are centimeters. In the height, we said we shall only subtract 5. Why? Because the other side on top it's not covered. So it becomes 155. Don't forget these are centimeters. Don't forget that. All right. Hence, use by calculations. Hence, show by calculations that the internal volume capacity of the trough is 8,091,000 centimeters cubed. So they have given the formula here already. You remember we are looking for internal volume. So you come here, you will say what's my new length? It's the breadth is 180 times 155. Did. That is the answer. We are using, they are saying hence. So simply meaning you're supposed to use the values that you find here. These are the values that we are supposed to use. These are the values you are supposed to use. Given that 1 gallon of paint covers approximately 280,000 centimeters squared, Mr. Nsondo claimed that 3 liters of paint will be enough to paint the internal surface area of the trough. Verify using calculations of if his claim is correct. You may use a formula. They said you may use a formula, but when you look at the formula critically, it does not cater for what we said. It does not cater for an open. It does not cater for an open rectangular prism. So we said, yeah, this one here, it's supposed to be 1, not 2. Why? One side is open. There are not 2 sides. So we only need to look for the area of only one side, which is the bottom. So if you having removed the 2 here, then these other ones are okay. So we start inserting. Remember they said internal surface area. That means we're using the internal measurements that we got. Together, the length, we've got it as 290. The breadth, we've got it as 180. And the height, we've got it as 155. These are centimeters. So these are the values that we got in the first place, which was these were the internal values. So now we come and we substitute them into where we see the L, we put the value. Remember, we removed this because it's an open area. It has an open end. So we shall say plus 2 into L, our length to 90, times the height, which is 55, plus I'm adding, because this 2 here is the same as this, I've put it out. So which will become the breadth times. So that will become 290 times 180. 290 times 180 equals to 72 into 52,200 plus 146,170. So the total area that we need to cover here is supposed to be 198,300. So this is not rand, sorry, centimeters squared. So that is the area to be, the internal area to be covered, to be painted. Now, we are not proving the area to be painted, but we need the paint to be used. So we need to know the area to be painted. This is what we are doing. All right, this is supposed to be the answer. When you multiply this very well, you have to get the answer as that much. Yeah. So this is the answer. This is the area to be painted, but we are not interested in the area. We are interested to prove that the 3 liters will be enough for the paint. Now we shall ask ourselves, look, the spread rate is given in gallons. You understand? 1 gallon. 1 gallon covers an area of 280,000. So for us, we have an area of 197,900. So what is it going to be? So we shall do that and we cross multiply and we find out the answer, which is we divide it by that much. So in divide, when you divide, you end up having 0.076. These are gallons. So change them to liters because her claim is 3 liters. So if 1 gallon equals to this much liters, what about this gallon? So we shall multiply by 3, 3,785. So the answer is 2,75 liters. Remember, they don't buy in half liters. So approximately what? 3 liters. So the claim is valid. The claim is valid. 1, we had to look for the area. You looked for the area. Having looked for the area, you had to look for how much paint do you need? How much paint is what you got? You got it in gallons. You changed it in you changed the gallon, and you got your answer there. You verified the claim. 1, 2, 3, 4, 5, 6. Yeah. 8 what? 8. Look for the area. This is the area to be covered. This is the area to be covered. You get the area, you divide it by the spread rate, looking for the number of amount of paint. The amount of paint is in gallons. You've changed it to liters. You've got the answer, which is approximately. Then you've concluded. You've verified. That's how we get 7 to 8 marks. 7 to 8 marks. All right, someone will look at this. I have substituted for letter by letter 2, L, L, H, 2, W, W, H, H. And I got my answer as this. I put everything into the calculator. So I've looked for the area. And good, I have now the area to be painted. Now, I come on and I look for what we call the the spread rate. What we call the spread rate. The spread rate is 1 gallon. 1 gallon equals 1 gallon covers an area of 280,000 centimeters squared. I have an area of 197,900 centimeters squared. So how much paint do I need? So what I said, 1 gallon, but 1 gallon is the same as 3,785 liters. So I said, okay, that means that if I have 3,785 liters, I can cover an area of 280,000 centimeters squared. But now I have 197,900 centimeters squared. How much do I need to cover this much? So I came here, I did this, I cross multiplied the box multiplied with this. That's why I have this. Then this number here multiplied with this. That's why I have this now on top. Because I'm looking for this box here. I'm looking for this box. I'm looking for the answer in this box here. What do? I needed to divide by on both sides. In that I remain with epoxy side. When I divided this, I ended up having 2,675 liters, which is approximately 3 liters. 3 liters, and I did need to conclude, which becomes valid. Why am I saying valid? Because the claim it says 3 liters will be enough. You understand? Yes, indeed. We need 2,67, which is enough. So 3 liters are enough. So the conclusion is what? Valid. So we have area, well and good. We've divided to look for the number of liters, well and good, from gallons. I multiplied that 1, 2, 3. I get this. I concluded as this. So my verification. So 1, 2, 3, 4, 5, 6, 7 could be your substitution here again. So 1, 2, 3, 4, 5, 6, and what? 7. Question number 5, let's look at question number 5. It's still under paper 2. It's measurement, but we are looking at what we call the BMI. BMI is used to tell the weight status and health status of a given person. It's usually in children. It's usually in children. But what does BMI stand for? It stands for body mass index. Body mass index. All right, let's look at this. Doctors determine a person's weight status by estimating or establishing their body mass index, the BMI. The World Health Organization says that the BMI is between 18,5 kilograms per meter squared and 24,9 kilograms per meter squared. Probably is a standard. Now, this person here, I think is, I'll call the person K. K is a 1,62 meter tall adult whose weight is 88 kilograms. Calculate the BMI. So we have the height, it's in meters already, and the mass is in kilogram. And they have given the formula already. So this is straightforward. We shall say 88 divided by 1,62. Don't forget it has to be what? Squared. So when you get that, your answer becomes 33, 33, 33,53. Don't forget the units. 33,53 kilogram per meter square. The K struggles to breathe and consults her doctor with this problem. The doctor advises her to lose weight until the BMI reaches 25 kilograms per meter squared. Use the above formula to calculate the new weight in order to reach a target BMI. Now, let's take note of this. Now we have a BMI to reach. We have a BMI to reach. Definitely, the person is supposed to lose weight. You can't lose height. All right? So the height is already given in the scenario number 1, which is 5.1.1. They are telling us the height is 1,62 meters. Now we have the new BMI, which is 25 kilograms per meter squared. So what's missing? We need to know the mass in kilogram. So simple. What we are going to do, since BMI equals to mass kilogram over height in the meters, but it has to be what? Squared. So we ask ourselves now, if we have the BMI and we have the height, how are we going to get the mass? What do we need to do? We need to multiply. So simply meaning mass will equal to the BMI times the height. Height what? Squared. So which is our new BMI is 25 times the height, which is 1,62. Remember, it has to be squared. So the mass has to become, the mass becomes 25 times 1,62 squared. The mass is 65. The mass is 65,61 what? Kilogram. They said the new weight. They didn't tell us round off to the nearest kilogram. So this is 65. All right. So they're telling us determine the total number of kilograms K lost. Remember, initially the person was 88. Initially, the person was 88. This is the initial grams. Now he has got the new weight. So we need to know how much the person lose. So it's supposed to be 88 minus the 65,1. 88 minus 65,1, and the person lost 22 kilograms. Sorry, 22,39 kilograms. All right. Why give one advice on how to lose weight? One, someone should eat healthy food, should avoid junk foods. Two, they can go to they can exercise every day. They can get they can subscribe for membership in a gym and they practice from there every day. All right. There are a lot of advices that you may give someone there. State the healthy BMI range of a 12-year-old boy. They are telling us below shows the BMI for teenage girls and boys. Refer to the table and answer the following questions. Now we have the healthy BMI range, the overweight if BMI is good. Someone becomes overweight if the BMI goes beyond this. Now severely overweight, it's greater than this. Then healthy, overweight, and severely overweight. Severely overweight, that becomes obese. Ne? Okay, so now we are looking at a 12-year-old boy. 12-year-old boy. You will come here. This is the age, 12 year. This side is boys. So it's this much. That's the range. So the range is 18 to 21. Okay. A 17-year-old girl has a BMI of 31 kilogram per meter square. Name the weight category. Weight category. Name the weight category where she falls. Weight category. Now these are the categories that we have. She has a 31. Severely overweight. We shall say severely overweight. Severely overweight. 5.3, the growth chart below shows the BMI for girls. Refer to the growth chart and answer the questions. So these are the percentiles. These waves that we see, these are percentiles. Those are percentiles. Then they're saying Rachel is a 70-year-old girl whose BMI is in kilogram is on the 5th percentile. Estimate her BMI. So what we're going to do, number one, is to look for, you get a ruler. You get a ruler. Get a ruler. So having got a ruler, What you're going to do, because she's 17 years of age, come here to 17. Then you draw a straight line on 17. Sorry, 16. Draw a straight line. Right, you have to draw a straight line. Draw a straight line on 17. When does it touch the? Because this is a 50%. Then you draw another line like that, and in that you read off the values here. So this is 20, 21, 22. So the BMI is approximately. So a 17-year, when does it touch this? Because they said it lies on the 50%. So we are saying the BMI is 21 kilogram per meter square. That's how we do it. Yes, they're asking 3.2. Here we have the table to classify. They are saying, hence determine Rachel's weight classification using the table 2. Table 2 is this one. Now we said it lies on 50 and we got 21. So here the health status is what? Normal. Why is it normal? It's in between 18.5 and 21. And the state classification is what? Normal. Okay, refer to the growth chart and describe Rachel's BMI relationship to other girls. So we shall say Rachel's BMI is the median BMI, or you can say 50%. 50% of the girls' BMI is above or below 21. We're talking of girls in her age. All right. Miss M, an educator and a coach for hockey team at Victoria West High School, wants to raise funds for the new hockey attire. She decides to host Miss with the beauty pageant. All interested girls collected the entry forms. The summary of the entry is shown below in table 1. The children height, height must be at least the height must be 1.55 meters. Weight must be from 55 kg to 72 kg. Body mass index must be normal. So the N stands for normal. A, we shall find out in O, it's here. O only, it's obese. OW, it's overweight. Underweight, which is a U. The N stands for normal. That's the BMI. All right. So we look at this criteria also here. So they're asking us, calculate the missing value of A and B in the table above. The following formula may be used. So now they have removed it in the fraction form. Now they have written it in the linear form. What I wanted to do, remember, we have the triangle for distance, speed, and time. You can as well have the same triangle for BMI. You can have the same triangle for BMI. Don't lose hope. What you do it that way. Now, here we'll just use BMI equals to mass over height squared. You can do the same. All right. So let's go there and find the value value of A. What is it? Let's go to the table and find value of A. Wow, value of A, we are looking for BMI, which is straightforward. So value of A, it's BMI, which says BMI equals to your mass divided by the height squared, but everything has to be in meters. So what's the mass under A? A, the mass is, oh man, they changed it, but the mass is supposed to be this one in kilometers. Sorry, kilograms, not kilometers. Mass, kilometers, and the height is supposed to be in meters. Okay, this is A. So the mass here, it's 44, and the height is 1,55. So we come back and we substitute, and we shall say 44 divided by 1,55. Don't forget you square. So here the answer goes, and we say 44 divided by 1,55 squared. So here the value of A is 18,31 kilogram per meter what? Squared. Let's look at the value of B. Value of B. We go back to the chart, we check where B is. Wow, B is under the mass. So we are going to use this thing, this triangle here of mine that I've just drawn. So if you're looking for mass, what will it be? Mass will equal to B times height squared. The B stands for BMI. So we go back and we see, under B, do we have the BMI? Yes, it's what? 30. The height is 1,55. So we shall come down here. BMI 30 times 1,55. Don't forget it's squared. So the answer there becomes 72, 08. These are kilograms. Why are they kilograms? Because we are looking for mass. (5.4) Mr. claims that some of the girls did not meet the criteria and disqualified them. Identify the entrant who did not meet the criteria and specify the reason for disqualification. So that's straightforward. Remember, they told us the height has to be 1,55 meters. The weight in between 55 kg to 72 kg. That's what they are. That's what they were. Look at the scenario here. It says for someone 72 kg and if that's a weight, the weight has to be, and the height has to be at least. So whoever exceeds this, you don't qualify. Whoever exceeds 72, you don't qualify. So here we come. This one has already been disqualified, though it's normal. And the BMI must be. Oh, wait, they said the height must be at least. Okay. No. This one's fine. At least. Simply meaning this is the minimum. So this is 62 normal. Why? The weight is in between. Okay. Then we have this. A was, because the value of A as 18. Sorry, we got the value of A as 18. We got the value of A as 18,3. 18,3 using the table here, 18,3. It's normal. It's 18, this is also okay. Normal. So people who didn't qualify is 1, 2, 3, 4, have figure number 7, 8, 12, 14, they don't qualify. 7, 8, 12, 14. You can say 8, 12, and 14. Because they are over, they are overweight. They are overweight. She works and lives in Pearl. She is planning to visit her grandmother in Ladesmith and then her cousin in Port Elizabeth during the December holidays. She will spend a week at each of these places before driving back from Port Elizabeth to Pearl. Annexure A shows the strip chart of a route from Cape Town to Port Elizabeth. Use the information in Annexure A and answer the questions that follow. Number 1, take note of this. The person we are looking at, the person stays in the person stays in Pearl, but she's planning on visiting the grandmother. The grandmother is in Ladysmith and a cousin in Port Elizabeth. So we are from Pearl. So we shall start from Pearl. We go to Ladysmith. Then eventually we go to PE. All right, let's look at the next step that they want us to look at. Write down the number of national roads shown on the strip map. This is the strip map that we see. National roads will start with N. We have N12. This is 1. Scroll down. Wow, we have N2. This is 2. Then we have N1, which is what? 3. Is there any other national road? We don't have any other national road. The national roads that we see here are 3. All right, they said write down the number of, they didn't say list the national roads. So we have 3 national. Have 3 national. 3 national roads. Identify the national parks shown on this map. Identify. Because we'd have gone to the map and we identify, we take them off. But then anyway, you may mention them. All right, see the identification they said under the map, they say, note, NP represents or refers to a national park. So how many NPs do we see? Start from up here. We see there's one here. So 1 NP. We've got another NP here. So they are 2 so far. We come down, we look for NP. In other words, they're represented by these boxes. Where you see a box like that, there's a national park. You see that? Those boxes identify the national parks. So we go on and we say, identify the national park shown on the map. So we've said we have Ado, which is NP. Then we went to Tik. Let's see, Tsitsikama. It's another NEP. And the last one is Bonte. Bontebok. NEP. That's what we are identifying. All right. Determine the total distance from Cape Town to PE. We go to the next chart. Now, this is PE, Port Elizabeth. Where is it coming from? It comes from Cape Town. Oh, it's from 0 to 779 kilometers. So you write there and you say 779 what? Kilometers. Excuse me. The distance between Swollen Dam and Riversdale, we say we shall go to the map. We shall check it's from here to here. And we shall say, now, since Riversdale lies, you see, on this line here, which is the same as this much. Also, Swollen Dam lies on this line here, which is the same as this. This is 555. So we shall look for the difference between these two. That's why we had to subtract here, and the answer becomes kilometers. Or if you don't want, you can also use this other right-hand side, which is from 224, it has become 304. So how much distance is in between? Still, you get the same answer as what? 80. So we shall take it to be 304 minus 224, which the answer became 80 kilometers. Now we are calculating the distance between Pearl and Ladysmith using the National Road and R. So what we need to know, Pearl is here. So from Pearl to reach the other place, from Pearl, you need to come to Cape Town. So we are saying Pearl to Cape Town. Then Cape Town, you need to go up to Riversdale because you're going to Ladysmith. You cannot continue, so you turn it on the side. So plus Cape Town to Riversdale, then Riversdale to Ladysmith. So from Pearl to Cape Town, we are looking at 51 kilometers. It's 51. Then Cape Town to Riversdale, Cape Town 0 to Riversdale, 304. Then Riversdale to Ladysmith, from here to there, this is the distance, which is 82. So we add on 82. So we are saying Pearl to Cape Town, then Cape Town to Riversdale, then Riversdale to Ladysmith. So Pearl to Cape Town, we've already seen it as 51, plus Cape Town to Riversdale, we saw it as 304, plus Riversdale to Ladysmith, it's 82. Ask yourself, what answer do you end up having? You add them up. It's approximately 434. 1 plus 04 plus. So it's 437 kilometers.